I mean, in terms of today and tomorrow, what we'll be reviewing is kind of in the tradition of the DRL presentations, is a kind of broadcast review of basically 16 months worth of design research that the students have been working on over obviously challenging circumstances, but at the same time, I think in a spirited way in terms of helping us to try to define what we've been calling social ecologies. The reality around a lot of the subject matter that we'll be looking at over the 2 days is basically building on research that we were developing in terms of like living, in terms of issues around culture, and in terms of work. And that somehow manifested into kind of trying to explore maybe more participatory, maybe more co-authored ways of working, and explore a lot of the computational aspects within kind of real-time environments. So the 3 studios that we'll be looking at, we will be kicking off with one of Patrick and Pierre Andrea's projects, which has been building on this kind of thesis of parametric semiology. Patrick and Pierre have been working with the students on notions of a co-authored urbanism. They've been working on a large site in London around the Thames Gateway to look at really high density and to look around issues of ecology, particularly in relationship to flooding and some of those aspects, and to see how those elements in terms of hydrology, in terms of thinking about operational landscapes can somehow be embedded in these kind of large-scale developments. They've been looking at a lot of ecological aspects in terms of performance of towers, and a lot of the research has been engaged with structural optimization as a strategy to kind of embed both analytical kind of ways of exploring the tower topology coupled with kind of design sensibilities. In parallel with that, Sajay and Alicia have been working a lot around the subject of looking at settlements, in particular, looking at gamification and strategies around trying to look at different audiences and players within a framework that allows people to kind of co-develop strategies that couple sometimes economics, different kinds of competing, let's call it processes within the way that living, working, and design urbanism is actually met. So sometimes they're negotiating between planning systems, between personal kind of living decision-making. So they're somehow embedded within the thesis of using a gamification strategy to think about how we can look at future development strategies and enabling more of a participatory means to do that. In my studio with Mustafa El Said and Apostolis Despotidis, we've been looking really at control systems, in particular to address post-disaster scenarios. A lot of the projects that we've been looking at have been somehow coupled between design strategies for a kind of deployable and anticipatory architecture and control systems that have been modeled on land, sea, and air control, also looking at Amazon warehouse and looking at the subjects in terms of an autonomous architecture that has the ability to be deployed for particular issues. Some of the issues are dealing with mass migration and the kind of deployable housing for water-based urbanism. Some of them are around augmenting the existing hospital with bringing the hospital home. So the subject matters are around these kind of complexities, more real-time thought processes and distributed kind of networks of agent-based systems. In somehow putting together all of this work with the staff and the students, we made a small microsite that basically lists all of our guests, and we're very fortunate to have a lot of critics who are sharing in this kind of conversation with us. And as this is the beginning of an agenda, I think all of the comments are as open and diverse as we can in terms of engaging some of the subject matter from your perspectives. The way that we've structured it is that we will look at 3 teams in this first session. We'll take a break for an hour, and then we'll continue with 2 teams, bringing the first day to a close with Albert Taylor, who is lead technical consultant who will be giving the DRL keynote tonight at 6:30. So we encourage everybody to join. In terms of the brevity of time, I would just like everybody to have a look at the microsite to see the backgrounds of all of our critics. Instead of listing them everybody now, I'm welcoming everyone because I know that it's a very complex period of time, so we really appreciate all the effort that people are making to join us in this endeavor. I think the students and the staff have tried to put as much effort as possible to create an event in a similar kind of spirit like the culture that happens at the AA and the lecture hall these days. And I think we're very much looking forward to the discussions today with you guys. We will be joined by an audience of students who are following, families and friends. So I think all the conversations, I think, are really to kind of unpack, I think, some of the issues around some of these subjects in a kind of unapologetic kind of way of somehow discussing this kind of work. So with that, I just want to thank everybody again for joining. And yeah, we'll have the presentations for around 20-25 minutes per student group, about an hour for each of the teams. So thanks everyone. I think with that, Pierre-Andrea, if we can ask the first team to launch their screen.
And good morning, Ross. Great to have you.
Yeah.
Hi, everyone. Okay, first team, I think it's ready now to present. You can start to share your screen. Thank you.
Hello. Can you guys hear me?
Yeah, introduce yourselves in the studio.
Right, okay. We are the first team in Schumacher Studio about social ecologies. My name is Hao Wen.
My name is Peng Cheng.
Right. Yeah. Yeah. Okay. So, sorry. All right. First, we look at a brief introduction of our thesis. So our proposal aims to create an assemblage of social ecology through a rich but cohesive, multi-authored and densified urban district. The primary ambition is to generate an urban area with a characterful, varied identity that achieve a balanced order between unity and difference, avoiding both the sterile and disorienting autonomy of centrally planned modernist cities and the visual chaos of agglomeration of utterly unrelated interventions, as we find now frequently. The proposal envisions a new high-rise district between the City of London and Canary Wharf, straddling on one side of the river. So through a thorough research process, our project evolves mainly out of 3 principles that are taken into consideration. The first one is ecology, the next one is topological organization, and third one is phenomenology. So here we'll look at the first background, ecology. The study of ecology is categorized into 3 parts: sunlight, wind studies, and flooding. All of these have potential hazardous conditions that calls for some level of design research. Yet to understand the concept of ecology, which is a living network of information exchange, we realize whatever strategies we employ is no merely a resistance or protection towards these weather conditions. We need to utilize them, translating differences of weather conditions into spatial and programmatical and clustering differences. So the first part about ecology, we look at flood simulation, flood strategies. With the extreme climate change that we are going through right now, the rising of water level is one of the most inevitable issue we need to focus on. Based on the data collected by NASA from 1930 to present, each year the global sea level rising is at average of 3.3 millimeters. And with the help of flip simulation softwares and topographical CD files of our site, we're able to generate a rough understanding of flooding pattern on our site. We're also interested in the mutation of topography as water rises. Different readings of land clusters can be achieved in relation to the water level. Next, we're looking at the sunlight analysis. For sunlight, London has an average sunlight of 190 days, which means an annual total of 3,600 sunlight hours for an average 200-meter tower. Furthermore, daytime hours vary significantly during summertime and wintertime. For a tower with an all-glazing facade, energy losses are tremendous. Our design tends to employ the use of operable facade elements to control the thermal condition on the interior and of the vertical towers, and also map differences in thermal conditions to different programmings. And next, we're looking at the wind analysis. Britain's unique weather condition is dominated by jet streams. This narrow band of fast-flowing air high in the atmosphere is driven by temperature differences between cold air of the north and warm air to the south. London is mainly affected by prevailing winds from west and southwest directions. The maximum wind speed exceeds 16 meters per second. In addition, wind speed is further accelerated by the narrow building distance in London's urban area. So we intend to analyze optimize tower massings to mitigate the impact of horizontal load, which is generated by the wind. The second big part of our background is about topological optimization. Ever since Bensel published his paper of optimal shape design as a material distribution problem in 1989, this method of structural optimization has been continuously integrated in the design field. As a result, topological optimization tools has become more and more integrated with the capital A architecture. In recent years, the topological optimization driven architectures have gone through several iterations. In the example of Quad National Convention Center, it was a mere cladding representation in SOM's competition entry of CITIC financial centers. An extra skeleton scheme is optimized through this strategy. And later, for the most recently built 1000 Museum by Zaha Hadid, spatial rhythms start to be informed by structural rhythms. So for our research, we ran through several generations of benchmark generation. From initial tests of simple geometry, gaining a basic understanding of the preferences of different TO softwares, to skewer geometry domains, testing the limits of these softwares. Then finally come back to a more controlled domain, generating a complex but legible structural benchmarks. So the third part is about phenomenology and multi-authorship. Our proposal will develop a multi-author urban district with a characterful internal varied identity, creating unity across differences, differentiation within unity. We look at that field of phenomenology, which in this particular case called for further differentiation of design object. We are offering different readings of the district from different user perspective and from different point of view. Sorry. So first we look at the co-authorship. We use topological optimization generations as a main driver for tower semiology. The benchmark generated by different method with the same setup will have different configuration with similar structural behavior. Another aspect is the view-dependent Gestalt switch. Our intention is to have tower configuratively match only on certain views so as to generate emphasize on magical point on the site.
Based on the three topics we just mentioned, we did a series of research and experiments to support and push our design going through the steps of flood simulation, and ground design, and tower distribution, and structure and materials, and program and microstructure, and facade phenomenology. We will then show the three parts based on this logic. So the first part is ground strategy. Based on the particle simulation, we can predict how flooding will hit the site area. And by extracting the vector line, we get position and vectors and flood. Thus get the original pattern and set our positions and network logic. And then we did a second version of simulation with towers as collisions and get a new pattern. That's to decide the ground area to prevent flooding and river path area to get the flood go through and reduce the pressure of the flood. As water level going higher, the ground pattern will change from the whole shape to medium size and finally become some island, which reveals shape phenomenology. And this shows the primary river and the secondary river will set at different altitudes. And we distribute towers by hybrid logic. From the land clusters, we get the first distribution of different shape types. And from the view of canary wolf, we're gonna get a gradient of material change. The final outcome of towers is an overlay combination of these two logic. And this is the overlap of division showing our urban reading. And next, we are looking at tower strategies.
So first, we look at the topological difference between different topological optimization methods. Our benchmark generation is supported by 3 main softwares: Paragreen, Amoeba, and Topos. They vary in both low-pass generation as well as geometry interpretation. First, we look at the logic of Paragreen, which uses SESO processing, which is single-directional material optimization, to generate low-pass and discrete piping method to interpolate the low-pass into geometry. For each iteration, low-pass is static. It only gains more resolution throughout through the iteration. Next is the software Topos. It also uses the SESO algorithms. It only has some minor differences for low-pass from Paragreen. For the geometry output, it uses Martian cube scheme to generate a holistic mesh. The third software is Amoeba. It uses bidirectional material optimization, which means for each generation, low pass becomes dynamic. It outputs varies with the previous 2, even with the same setouts. So next, we're looking at the catalog of our benchmark studies. First, is the result of the topos. We found the most prominent shape is a branch-like structure. Next is the results of Amoeba. We use a mirror method to make the benchmark more holistic, forming larger floor plates in the middle. The Paragreen studies are divided into 2 groups. We first look at a series of points set out that spread evenly inside the typical domain. The results form a typical diaphragm moments that are very typical in a steel tower designs. Next, we start to manipulate the void conditions of the domain, forcing low pass to grow differently on every level. The resulted benchmark have stronger vertical connections, which is oftentimes cross-bracing. Then extracted the skeletal lines and void conditions of the 4 groups mentioned above, and studied the void configurations of the group. So from the void configurations, we categorize them into 4 groups: type Y, type H. Type Y that is generated by Topos with the branch structures. Type H generated by Amoeba has strong middle floor plate. Type Z generated by Paragreen, which has a strong diaphragm moment. And type X that's also generated by Paragreen. After the benchmark generation, we also started to assess our benchmark models. We first extracted an anticipated building system from the original benchmark and applied horizontal and vertical forces. Based on structural analysis of the software, we look at how the stick model distorts. So from the previous results, we start to add additional structural members and slabs to stiffen up the structure, and that become the a kind of translation logic for our benchmarks. So next, we're looking at the translation of different tower types. So here we're looking at the Y type. Here's the type H type. Here's the type X type, and here's the type Z type. So for each type, we translated the exterior skeleton, the floor plates in the middle, and also a facade system. So this is showing the H type. Here's the Y type with the floors and exterior facades. Here's the X type with floors and facades. And same goes to the Z type. So from the previous translations, we started to assemble a matrix of our tower translations. Mainly, we have on the horizontal axis, we have 4 different types, which is type Y, type H, and type X, and type Z. On the vertical axis, we have different materials, which is concrete, timber, and steel. Each type has 1 or 2 material types, and overall they form kind of a matrix that relates to the urban reading that we mentioned earlier. Okay, next is about hybrid type. Shrai, can you continue?
Okay. So now we look at the design of the hybrid types tower. This tower will later serve as an intermediate transition between the main structure types. Next. For the benchmark generation, we first split the domain in halves. Mirror point set out as well as the load support set out. Line point loads on the same elevations. The 2 halves are generated by 2 different softwares, achieving similar load paths but different results. For the rationalization of the benchmark model, we make sure primary horizontal support are connected so as to bind the two halves together. We apply the same strategy to X and H type hybrid tower, and also to the X and Z hybrid tower, and to the Y and H hybrid tower as well. So
this part we are looking at different scenarios of connectivity of our proposals. So for podium design, we mainly focused on the relationship between the tower and the ground. So firstly, from the flood simulation, we can get basic circulation guidance. And and except for podium, we still have bridges to connect the land clusters between the. This one. Oh, sorry. And we do further modification based on the network theories and connection study, also regarding to the program of each tower group. So this podium lines will become the first part of the overall connection. And except for podium, we still have bridges to connect the land clusters between the river path, and also tower bridges for higher level of connection between the towers. The bridges that sit across the river are fused with the hybrid towers to function as a transition between tower clusters. And here shows the hybrid tower transition. That's right.
So due to the variation of the structure lines and void condition presented on each type of tower, out of the 4 tower benchmarks, type X, type H, type Z, and type Y tower, we make a series of bridge structural optimization study with different setup strategy. Next. Here's the catalog, and we finally select 6 types of a connection strategy for tower connectivity. Next. We apply the selected bridge prototype to several different conditions for bridge connectivity, according to the key elements and characteristics from type X to type H, from type Z to type Y benchmarks. And also we have a best strategy for the condition with long distance expansion, and also this condition for ground bridge across the river path as well. Next. Here's the catalog for bridge catalog for type X and type H. Next. And for type X tower, we use the bridge structure to simulate in response to the crossing moments of type X tower. And the supporting part will attach to the original exoskeleton structure. Next. And for type H tower, we use very similar strategy applied to the connection of type H tower with a bridge moment in between. Next. Yes, and the bridge catalog. Next page. For type Z tower connection, we follow the zigzag moment and generate the bridge with the same strategy to connect the 2 main sections in different levels. And for type Y tower connection, we simulate the branching tendency by generating the arching movement. Next. And then it's for the long distance expansion strategy. Next. For the long distance expansion, we use hybrid tower as an transition terminal with support of bridge within the main structure of the hybrid tower. And the bridge part will branch out, approaching to the tower on both sides. Next. And another strategy is to reinforce the original exoskeleton structure for the long distance expansion. Next. And the last part is for the ground bridge connection strategy. Next. We apply the bridge on the lower level across the river with a hybrid tower, so that the hybrid tower serves as an interface tower between the 2 different land clusters. And then in conclusion, our proposal have 4 levels of connection. First, the ground terraforming that change for holistic to staggered islands as water rises. Second, a tower podium that serve as an interface between ground and towers. And third, hybrid tower and tower bridge that connect different tower clusters. And the last one, a live rail system for autonomous vehicles that connect to individual towers.
Yeah, here's just an overview of our design at this point. So the third part is about, sorry, the third part is about program distribution and higher details. So we first categorized our programs into 4 big catalogs: residential use, corporate use, commercial use, and facility use. For residential use, we have student dorms, a luxury apartment, event space, reception. Corporate use, we have open shared offices, small meeting room, rest area, large meeting rooms. Commercial use, restaurants, supermarket, gymnasiums, cinema, theater. Facility use, we have library, galleries, garden, education center, etc. We also plotted these different types in terms of degree of privacy, which is all about enclosure of space, and the degree of interaction, which is a more static or dynamic condition of circulation to later distributed in more detail in our tower. So for one single tower, we still follow the basic principle of skyscraper design, which is having supermarkets at the bottom level, open office corporate use at medium floors, and then residential use at the top level. Since our benchmarks to promote this coreless, large cavity large void designs, we envision that this cavity will become a space where different programs start to interact with each other. So in this particular case, we look at a little library condition fused with a smaller open office, a green space, a restaurant, and some rest areas. Different facade moments are also related to different programs inside the towers. So for the main void that's facing south, we have the parametric things. For the main sky garden levels, we have a large public balcony. For the smaller residential areas, we have segregated residential balconies. For our urban program distribution, our proposal utilized the structural matrix generated after the benchmark translation, a binary of reading of urban social life is enabled by the matrix. Okay, so first we look at the structure types X, Y, H, X, and Z, which relates to the 4 main program function groups. Okay, so Y tower has larger floor plates, more openings, and was assigned to commercial use. H type has smaller floor plates and more privacy, assigned to residential types. Z type has larger openings, smaller floor plates, was assigned to office corporate use. X type has more sky gardens and opportunities, was assigned to facility use. The second urban reading comes from the material types, which relates to the percentile of the main program usage. So steel and concrete on the 2 sides, they have higher proportions of the main program. The timber cluster sits between the steel cluster and the concrete cluster and has less proportion of the main program, such as promote more opportunities with the hybrid types of programming. This way, the more dynamic programming distribution of timber towers start to transition between steel and concrete, which is more static program distribution. Here's an overall program distribution of our towers. In this particular case of a typical timber tower, a sectional vertical sequence starts to appear that binds all the different types of programming usage together. So in this particular case, we start to see luxury apartments, a sky garden, open office, education center, and retail and commercial use. Finally, the hybrid tower and tower bridge become hybrid programs types as well, interfacing different program groups. We also design different circulatory system into our towers. So the main floors will serve as horizontal main circulation. The elevators that sits outside the facade becomes a multi-utility vertical circulation, public vertical circulation that is connected to each floors, and then residential vertical circulation that is only accessible for the residential areas. Same goes to our different types of towers. For the bridge type, we also incorporated the bridge as a part of the link circulation. So next, the last part of the program distribution is about operable microstructure and adaptable programming. We first did a study of a timeline of usage of our different program clusters. So we realized what the strategy we employ needs to fit into the agenda of dynamic programming distribution. That's why we started to do a series of different microstructure that talks about a change of programming and change of usage within our space. So in this particular case, we're looking at a library that is suspended by a rigging support system, which is then connected to the main structure. The capacity of the library varies in conditions. So here we're looking at a 40 bookshelf stack versus a 70 bookshelf stack. Next, we're looking at a residential cluster with a plug and play types of partition walls and floor plates to accommodate different usage of the residential usage. So for different stacking schemes, we'll look at luxury apartments, a scheme with more luxury apartments, and a scheme with more studio or motel space. The same goes for the office space with rigging suspension systems. So here we're looking at a space that varies between open office, smaller meeting rooms to larger auditoriums. For our tower bridge, we look at moments that are supported by hydraulic arm and rigging systems, which will offer different levels of connectivity between the towers. So based on the connectivity, we have public balconies that are only segregated between the two towers, or an open office that is connected between towers, or Sky Plaza that is half connected between the towers. Okay. Here, I'm just showing the renderings of some of the programs we talked about. Here is an office. Yeah, next part is about operable facade and facade layouts. You talk.
So, in order to cope with the influence of sunlight on the ecology inside and outside the tower, we use kinetic facade on some parts of the tower's exterior, trying to explore the practical application in direction phenomenology. The movement trace of the variable scale on the north side of the towers in London is not obvious, so we roughly divide the tower around into several segments. The variable scale is mainly used on cells. Balconies and static scales are used in other locations according to their functions. And we have several kinetic facades to cope with different sunlight levels. And we did an experiment to test the shading performance of each type of facade in one day. We can clearly see that after adding the facade, the sunlight hours is greatly reduced. Then we tested other performance conditions. What can be concluded in our model is push-pull scaling has the best shading performance, and the folding scaling is the worst. Then we assign these kinds of kinetic facade to our tower group according to two logics. These are the locations that require variable scaling. The first logic of facade distribution is natural difference of the tower group in light, which is caused by the shape of the tower or surrounding context. Then we color-coded it. Yellow group means enough sunlight needs dynamic shading. Green group means normal sunlight, part of the sun needs static shading. Blue group means less sunlight, no shading requirement. The second logic is the difference in main functions in mutual positions of towers, which results in different privacy. Yellow means the most public area needs dynamic shading. Green means normal, and blue means the most private residential part. Finally, we combine these two logics to guide the distribution of our kinetic facade. And next slide.
Okay, this is the renderings of facade. As for the last part, we are going to show some renderings of interior and outside space we've just mentioned. And this is the overview of our project sits on the overall site of our studio. And here is Y type and timber tower. We can start from the podium level.
Hongchen, hello. Hongchen.
And then we get on an elevator. And here we can see, sorry, education center,
Internet is not stable. It's okay.
gallery, and finally arrive at the platform or shopping center. And here is a light rail system for autonomous vehicles. And following the light rail system, then we will arrive at the station. And get off the station, we get to the Z-type and steel tower. And this is this is the podium. And here we can see the overview of kinetic microstructure moving. And then we get to the roof plaza, seeing the view of the whole site. And this is the H-type residential tower. We then go on to a tower bridge into another hybrid tower. And here we're getting over the kinetic bridge, which changed from disjointed to connected. Okay, and finally, we look at the fly-through of overall project. And that's all. Thanks. Okay, that's all.
Okay, thanks, guys. I think you can play this again just in the background, and we can open it up for conversation.
Yeah, we have an overall video.
Yeah, thank you.
Maybe get started with some comments. Is that okay?
Yeah. Go ahead.
I mean, I think first of all, it's commendable the ambition that you guys took on the research and all of the different scales, materiality, structural principles, right? I think spatial conditions. And it shows in the initial catalog of research that's quite impressive. It's very well documented, right? I think it's a great effort and very well developed in many aspects. But I think in a way that also creates some of the difficulties when you tackle so many aspects, right? I think one of the main key points on the early on points that I can highlight is especially this that is now on the screen. Right? You create this analysis from the site, from the river overflowing, the location of the towers in the podium, but then I have a problem with this. I understand that the towers are just indicated initially as cylinders, right, with similar size, similar typology, similar size. But I would have wanted to see, as you develop the catalog, that you start analyzing the responsiveness of each typology. I think otherwise they become completely independent from the podium, the ground condition, and they just reflect an expression of either tapering or making atriums, where it could have been much more richer, that you do see that the placement of the towers inform the program, then inform the structural qualities, the material qualities will inform back the structural principles. And I think that will result in a much more identifiable composition when you start looking at this at the end, right? I think that's where, in a way, it's quite hard to believe that your catalog is so precisely done, because it does become a bit of a very homogeneous looking towers, right? And I think it's good to have this familiarity as you go along, that the exoskeleton is the predominant feature of the towers, but it's not so clear, besides the coloring of the timber and not timber, right, that you have, that there is no coherency on density when it's a timber structure or a steel structure, you know, how the responsiveness of the bridges, connections. I think there is, obviously, as I said before, the ambition is so high that I understand that the time might not be enough to go to that level. But I think there are aspects that would make this a much more unique project. You know, you take full freedom on the placing of the towers, the flowingness of the podium, but then you go with a very standardized floor plate for each tower and a very standard way of just connecting them with bridges, which I think that could have been also showing a much more higher level of ambition as well from the design aspect, and would potentially would have made a much more identifiable resolution of each of the towers. But I think overall, I think it's quite ambitious and quite well technically quite commendable, the amount of development you guys reached.
If I may add to Paolo's comment, I'll agree with you with him that you have very extensively tried to take in multiple factors and respond to them. I think, to me, the question that was left a little bit unanswered was the element of exchange both with the existing environment. As you say, you responded to looking at the ecology of potential flooding, at the sun and wind. However, there's a question of how do the towers and the structure around them have an exchange and a dialogue with the area around when there isn't flooding, or where there's partial flooding and there's river, there's a flow of water. How do the bridges between the towers, as well, the connection, could allow for exchange on a human level in terms of creation of community? So the tower, sort of, how does the tower environment have a dialogue and a relationship with the ground environment? And in the same way, again, I think a point Paolo made about variety and distinction. I think by looking at those points of exchange, as each topology is different, you would have an option to create an increased variety and identifiable variety for each of the elements of the tower network. And I also, there's an element, I guess, as well, to take further potentially on the material use in that exchange, on beyond kinetics, when you look at interface with solar energy and wind, of potentially other material systems and the use of glass, or the use of the structure of the facades in a way that can work synergetically with controlling sun energy into the building, cycling wind energy, and how that actually can help with the performance of the building in terms of heating, in terms of ventilation. So that was a point to reflect on.
I just feel urged to come back a little bit on what Paulo is saying. I mean, these kind of projects, they suffer, of course, from the difficulty of condensing 12 months and 100 hours of intricate debate into half an hour. And it's difficult to take in the kind of the coherency. I mean, I think this presentation was very strong, by the way, guys. I feel it was very rewarding to watch in terms of the overall order, in terms of the ordering decisions of types of structure, type of materiality, and the programming strategy. I think it's quite clear. But when it comes back home at the final visuals, I think it's there. Of course, if you have over 30 towers, Paulo, you can't quite call for an individual tower to be graspable. They are all individual and different, but you won't be able to perceive clearly as groups, and also types of material and facade in the tower, and they're quite different, and yet they are, of course, through tectonism similar. I think it works on many levels. I love the overall sensibility of lightness and transparency, the intervisibility, the voids, the microstructures. So there's a lot of things there, and I think that some of the criticism, throwing back at you, Paulo, is not lack of the project, is lack of taking it in. So I've been with that project and for many weeks and hours. So I think it is fulfilling the ambition more than you can take in by glimpsing it. And I make one criticism of the presentation, which wasn't picked up. I mean, it's been very responsive to criticism. It's a much better presentation. But when you go through all these abstractions and diagrams and you talk about voids, throw in these renderings already. When you talk about the facades, you know, you have to allow people to get the visual grasp, and also it spices up the presentation. I think next time, then you had a chance to familiarize with the characters, the cast of characters, and when you then look back at the urban, you recognize them. I mean, it's really a lot is in the end in building up the presentation so that you actually an audience can actually take in what you've done. Ross,
hi everybody. Yeah, can you hear me?
Yeah.
Yes, we hear you.
Yeah. Well, hello. Happy New Year to everybody. Look, I really love this. I don't know. I mean, of course, we've seen a lot of things like this, but this sort of touched something with me. I made some notes. Generally speaking, I don't know if you can see my screen, but there's a red thing behind me here. There's a red tower.
No, you haven't. You don't have the camera on.
Oh, you don't. Okay. All right. Well, don't worry. Okay. Yeah, there's a red tower here. Can you see that?
Yes.
Yeah.
Well, that was about 10 years ago, and the studio looked at, architecture that responded to atmospheric conditions. So you arrived basically at a cylinder, which is how you guys started, and how those forces really can inform the design of that skin. I think it's an eternally relevant parametricism in the sense that you run sequences you bring the science and the physics back in, and it's absolutely beautiful. And this is something I've been advocating for years, that it's not really about sitting down and designing. I think it can design itself. So you have a number of, how can I say, agents there, which will allow you to think a new way. And I love this idea of the inevitable issue relating to the floodplain. So I think it's a genius topic. I see London in a new way. So that's one thing. The other thing I thought was really beautiful is the tri-material approach from the wood, the steel, and the concrete. I mean, that in itself informs three very different structural dynamics in the way that you make structures. And I mean, I know there's a whole trend now to build bigger and bigger structures in wood. There are issues with that, but that's an incredibly beautiful idea. So I commend you on that. I love that triangulation, and that within a cityscape, you can find that localized diversity just through the material. One thing is, though, I don't feel it near the projects. I mean, it's such a vast project that there's almost been no time left to look at how that would impact on interior spaces. I mean, a holistically wooden building, you know, with other materials could be kind of extraordinary. I mean, really drive that, get it back down to the chemistry, you know, material science, and run that through each of those programs. So I think that's really brilliant. And just some small details. I mean, the bridges that you were investigating, you know, you arrive at this Tower Bridge type drawbridge, which is incredibly archaeological. I mean, I think the idea of Tower Bridge hijacks with the Tower of London, the persona of London. And I think we've got to go way beyond that. So I was thinking that instead of something that's got this medieval, why don't, if you looked at like a shear rotation, you do the same thing, and you could create a vast sort of communal viewing platform that could be rotated to different views across the city, which would also relate to your information that's coming through on atmospheric condition. So yeah, I mean, I find it a very seductive project, but I would, because this is kind of my thing. So yeah, brilliant. Thanks. Thank you very much for that.
Thanks.
Yeah,
I
I
will,
think,
yeah.
oh, sorry, go ahead, Veronica.
Oh, thanks. Well, pretty much all has been said that I also want to point out, but I think you are brilliantly setting the parameters for this assemblage of social ecologies as you aim to do. And also my questions revolve around this, what is diversity or variety in this case? Like, for instance, when you talk about phenomenology, then you look at the vertical and you look at the facade, and I'm wondering that when you're doing the flooding simulations, what about the perception and cognition of ground level? And is there something that we could learn from the flood and then use really this flood energy also to create more varied spatial conditions? Speaking of the design of this kinetic facade, I started to wonder what is really kinetic? What does it mean in this context? That how could you develop this notion of kinetic further? And then my question is, what happens between those facades, in between those hybrid towers, and how to develop the hybridity further? Because I think the aim, as I read it from the description, is to really have an assemblage of social ecologies, but that points to creation of a neighborhood, as you are also showing in your renderings and in the diagrams. So how to bring life, be it human or post-human, into this project? I think that's my question, so that it would really create more diversified sense of place and connectivity, livability, because as has been said already, the experience of the towers is not that different from one tower to another, although there are beautiful variations in materials and structural strategies. So the question is that when you start to really think about what happens in between the buildings and what happens with the ground level, then the question also is about connectivity. For instance, looking at the future of where we are heading. I don't know. Here in Tallinn, in Estonia, we have parcel robots struggling in snow, and we need to take into account how they manage the traffic. So are the podiums and then bridges sufficient to actually create this also supporting diverse and varied landscape in between these towers? The questions are about enriching this homogeneous spatial experience throughout this whole neighborhood. And I see from the balcony diagrams this kind of a hint of what the human condition might be in those spaces, and from the renderings as well. But I'd like to learn more of what it really feels like to inhabit those spaces, and in that sense, and also in relation to that notion of variety, I think these function groups that, as you've placed them, could these be also looked into further, and also this allocation or distribution of materials that maybe it's a little bit mechanical at the moment, quite like the floor plates that just slit the beautiful vertical towers. So maybe your attention has been more on the vertical phenomenology than the horizontal one, or the multidimensional space that you're creating. So yes, that's briefly my comments.
Veronica, can I just make a comment there, because it just inspired me what you were saying. I think that there's an opportunity missed here for the hybridization of materials as they fuse into different zones. And the secondary thing is, for some reason, in what you were saying, made me think that why do buildings have to be rigid all the time? I mean, can't they be built with joints that have subtle movement? I mean, I'm sure they'd stand up. I mean, it's not a big engineering issue in a sense. I mean, it could be a directive in the way that, you know, you're dealing with wood, which, for example, is a living material. Why can't you enhance that, seduce that with some other idea, which may be more difficult in more rigid materials? But I just think that idea of this subtle 5% variation in rotation, or not even expansion, contraction, but that would give life to architecture. I don't know, just the thought. Yeah.
Like that.
Yeah, I think if I can kind of throw in a couple of comments. I think a lot of the comments are kind of pointing in some direction to be at this stage maybe aware of maybe some of the possibilities of working in a more design research kind of method in terms of an approach. Because I think, you know, Paolo's point about shape grammars of volumes and so forth, I think, you know, you've tested it and it's an amazingly ambitious project. At the same time, I think when we talk about exchange and interface, and when we're talking about the social aspects and the possibilities spatially, I think the way that one transitions from some of the kind of more analytical diagrammatic aspects and translates that into space, not only in terms of material, but in terms of possibilities of how the use cases could be, I think that that's the next step that the project should focus on. I think for a lot of us, I think we at some moment in time kind of get obsessive about certain kind of technical elements and technical refinements. But when I look at the overall, for example, each individual thing is done very rigorously, but the interfacing between them and the exchange, to use Nasia's words, I think it's an opportunity to see where the hybridity really comes to. I think particularly when we talk about the issues around densification, we want this to be, I think, very much a part of the city, and to see the relationship that this has as an urban generator, I think is really important to see it beyond, let's say, structure. So even if the studio is foregrounding kind of an expressive structural organization of space, I think it's important to kind of give use case scenarios of what that future would actually be like. I think that that would actually start to really talk about the possibilities that can be harnessed by not only vertical living, but with these kind of larger island strategies for territories, which I think do have, with this kind of dynamic flooding embedded within it, I think different ways of creating territories and managing space. Now, the point with that is not to actually segregate towers from the ground condition. And I think maybe some of Paulo's early points lead to the fact when one is a tower changes kind of shape grammar to become something other, you know, with how it interfaces with the ground, you know, between towers and all of these other things, those connection elements, those interfacing elements, I think they are beyond just physical connection. I think they actually do create opportunities for different communities to come together, different activities, and I think suggestive of actually how this can be a 24-hour city, which in some sense, when we talk about densification and look at the overall view, it has a, I would say, a more traditional skyline approach to the way that you're visualizing it. But I think the opportunities shouldn't be somehow undermined. I think you can explore that and push that even further to see how these floor plates, these connections actually really have agency to think about it differently. I don't think that that should be left open to the imagination. I think what needs to happen is how do we critically kind of develop strategies for space making and embed that with technologies, not in a kind of techno euphoria, but really in a way that you can start to see things more instrumentalized. If there are points of criticism, I think, like, for example, the light rails and so forth default in a kind of traditional way of thinking that the infrastructure is somehow segregated from the landscape. And I think that there are opportunities to try to fuse those in ways that start to think about infrastructure also as a kind of cultural project, so that we don't kind of reinforce the undercrops of things that we see in highways and other things. So I think the more that you can creatively use your architecture as an armature to somehow engage in some of these issues, I think the more, I think it will open up kind of possibilities. I'd like to think that the project as a research project is not just a proposal. So I think to do that, I would encourage in the next couple of weeks as you put your thesis document, as Patrick says, there are aspects of the research that don't come across because it's difficult to kind of overspecify certain aspects. When you look at the global image of the project, it's quite ambitious, but I think the ambition should not be miscommunicated in terms of just like trying to take over with a new vision, like in a techno utopia way, but I think much more in terms of critically self-assessing. I think what a lot of the comments are is differences that make a difference and how you guys see that with the sensitivity of actually working on this. But I think overall there's a good conversation happening, and I think we should focus a bit on the social aspects that these kind of architectures could enable.
Yeah, I think the book is very important. I think this also merits publication. Maybe you can also put the 4 projects together. And for that, I would say in terms of these visualizations, the end are great in the first user perspective, but go back and pick out some key renderings, static renderings where you can didactically compose the image and bring out the full strategic renderings, I would say. Make another series of strategic renderings for the book. In terms of diagrams and explanations, you're very strong. In terms of rendered documentation, there's more work required in terms of still renderings. Great. Are we ready to move on?
If there isn't any other comments, I think it's a good way to start off the day. Thanks, guys.
Yeah,
Thank you, guys.
Thank you, guys. Yeah.
Thank you. Thank you. I think next team is ready to present. Can you share your screen, please? Great, thank you.
Chan.
Okay, shall we start?
Yeah.
Yeah, guys, when you're ready,
Okay.
you guys can start.
We're Escape Team from Theo Studio. We have Ada, Sid, and Chen. So every 2 seconds, one person is getting displaced. Due to political, social, and economical reasons, people are forced to leave their homelands, seeking to start a new life. Millions of people embark on boats, trying to cross the national borders with uncertainty of arrival, while most of the people are threatened by dangerous environmental conditions during journey or end up being rejected outside of the border. In 2019, the number of forcibly displaced people reached to 80 millions by having the 27 million refugees arriving different locations around the world, which creates a huge problem of accommodating such high amounts of people. Mediterranean area occupies most of the arrivals. Greece, Italy, and Spain being host and transit countries at the same time face severe daily arrivals, fluctuating between 100 to 1,500, which mainly driven by sea transportation methods. Environmental factors and political issues standing as a barrier between land and sea result in the uncertainty of arrival state. It also reveals the problems of existing housing solutions, which are fixed finite architecture without being able to cope with this dynamic flux of people arriving. The suspended state between land and sea is where the existing system breaks down by not being adaptive and flexible. We believe architecture can deal with these age connections by creating this kind of in-between suspension state that interfaces between land and sea. In doing so, we are proposing a model addressing two particular issues. To manage high population, we looked for autonomous self-organizing models which are dynamically changing and transformative. Studio set up the problem to be able to look at different control systems in real time. Our project was researching sea control systems such as the port. Port is an autonomous system managing exchange of high amount of goods. It is a continuous sorting system driven by different layers during the process of loading and unloading containers coming from different directions. It is consisted by berthing, mooring, and intermodal transportation. Port system is a highly coordinated effort of transformation and transportation by having multiple infrastructures such as automated guided vehicles and cranes cooperating with each other and derive different functions by an automated system. Since land has certain restrictions, models that are may have capacity to create the opportunity to have much more flexible framework for the architecture should be introduced. We look at the history people live on water, such as Makoko, an informal self-organizing water-based urbanism. It is a human agency-driven floating city that hosts high amounts of people. It is adaptive to changes of the population, which means that the strategy of the settlement is not based on conventional blueprint understanding. One of the elements beside housing strategy is to keep the waterway for connectivity and circulation. It contains various types of infrastructures to satisfy the needs of people, such as educational, residential, and fishing features, while proposing them flexibility of mobility. And since Greece is facing the most dramatic number of arrivals and the land strategy are failing to provide sufficient shelter, we focus on the zoom between Greece and Turkey. Land strategy are locally designed for initial number of people arriving, although it is instantly changing, so the understanding is wrong. The camp are getting packed every day, while the intention of hosting people temporarily ends up being the undefined period, such as years. Zooming to Labos Moria camp, this is officially built for 3,000 people, but the numbers has reached 20,000 by cumulative arrivals. The resources planned for initial numbers do not have the capacity to support this kind of population plus people's basic needs. The existing responsive solution, either on land or on sea, are not only adaptive to handle this fluctuation of high population, but also different environmental conditions such as current, wind, and disasters. It is based on unitary system resulting in individual shelters without any interaction and circulation between each other. To interfere the suspended states, we are proposing water-based urbanism, consisting water infrastructure that are in highly coordination with each other. It is an agent-based self-organizing system consisting configurable units that has capacity to quickly aggregate either related to changes in environment or human decisions. This is how we identify our strategy by creating spatial organization by unitary agent-based models.
In order to figure out the process, first we introduce the automated system for transition state. The process is divided into two sections, which are transition and settlement. Transition state is where unit self-organization is driven by rule-based automation. Three different states are set for each unit, which are active, inactive, and connector. The active units will become the leader of the cluster, which will be followed by inactive units. Connector unit's function is to form the negotiation between clusters. Each unit has its own parameters, such as range of action and number of neighborhoods. Different modes have their own in-density range control, and each unit can adjust the different value to generate new agents. It is a rule-based self-organizing system consisting of reconfigurable units that has capacity to quick aggregate within the population. With populated amount of clusters moving at the same time, the rules can be generated by interaction between units and by setting different angle and detection distance. Path generation will become more and more obvious as the detection distance and angle become larger. As it is a water-based urbanism unit has capacity to negotiate with the environmental factors, which are introduced as vector field within the simulation. The entire system will generate the movement of units based on real-time condition and generate different patterns according to the environment. Although to protect units from different kinds of changes like water turbulence, and also take full advantage of current as external mobility supply. When we combine the previous research, the change of unit state, the adjustment of your own parameters and environmental factors will generate a clear agent, and the change of agent can dynamically display the change of pattern.
So the geometrical research starts from searching for a system that has optimized packing strategies, which can create a certain densification with the minimal use means, and is also useful for self-organization. We started with a circle packing system, and by introducing directions of aggregation and edge connections, units are optimized to pentagon shape. Pentagon can provide linear, directional, and packed aggregation to self-organize. By looking at the outcome of pentagon aggregation in a higher population scale, Pentagon has geometrical limitations to form a fully packed organization without breaking any edge connections. Hexagon, compared to Pentagon, can provide the full packed state, which is the reason why it is introduced into tiling system. The organization is based on a tiling system, and the tile is the base thing functioning all the same between units. Tiling system has geometrical restriction, so we try to augment that by creating configurable spaces that will allow us to think about the space within 24 hours cycle. Furniture is not considered as obstacle. We are designing a smart tile to be able to be programmed to address different kinds of functions of living, setting, and working. Our system consists of two units space generating units, which provide different behaviors and organizations. The mobility section locates at the bottom part of units with the inflation of airbags underneath. Water inside of the shell will be pumped out, while the metal contact on the edge can be used to contact with others and charge with it. And deformable tiles are on the top of the mobility section with the coordination between piston strategies and pressurized airbags. The ground of units can perform different deformation based on human decisions. The last one is the space generation section, which is a softer component with airbags allocating around inside of the body, with different parts of airbags being actuated. Different zooms can be pop up and generate various patterns.
In order to get full use of inflation strategy of the ground part, we introduce a new system named mode switching. We are creating a new system that allows people to customize their own space. Same universal tile is programmed differently within family aggregation, so it is human agency-driven process. Tile have two different modes, which are sleeping mode, relaxing mode. We try different configuration of living space to generate different volume for people to live in this space.
Farm and supply units are variations of the system to augment the capability of the system. Based on the aeroponic strategy, the farm units consist of cultivating plates where plants can be grown in the central area, while atomization device under it can atomize liquid nutrient, which can be easily absorbed by plants. Supply units are in charge of the supply transition between land and sea. It has a modular supply shelf which can be took out of the units and reload easily when they attach to land. After units reconnect to the body plan, people can have access to daily supplies that they needed.
After looking at housing unit aggregations, we look through special organizations of shared units, which can provide different activities to augment urbanism within the settlement. By using soft space generating system, creating semi-closed spaces which are united through edge connections within the aggregation expands the limitations of tiling system. We introduce floating structures which are supported by minimum of 3 numberhood. Different edge connections form different volumes for people to use for different purposes. Through shared zones, by using various edge connections, the united spaces can be shaped and separated according to people's needs.
After we figure out the deformation for space aggregation, we introduce the inflation structure into circulation units. Different aggregation has their own inflation. We divide into two. One is linear way and two is package way. In different aggregation, ground parts can inflate into different activities and infrastructures for immigrants to do the activities according to the need of them. In order to figure out where those units will reach at the position of them, we introduce settlement strategy to continue the process. Self-organization system is formed by a combination of CA and DRL system, through which we can identify the location of units is based on the neighborhoods and interaction between units. The aggregation of units are defined by rules that have 3 different patterns, which can also influence by different environmental conditions. They can reach to the right position and generate the body plan. Each cluster has its own detection range and possibility of attractive level. Attractive level is an essential parameter for the density of the body plan. The lower the volume is, the more dense the body plan will generate it. At the same time, dense body plan can have more space, more shared space, but less housing units gonna attach to the main body.
Since the settlement cannot expand without limit, when all the people already reach the nearshored area per day, the system will generate a second center to expand the settlement. The expansion is affected by the numbers of people per day. Once the centers have completed their growth, growth towards different directions. The zone in between them is used for connectivity matters. Circulation units connect two different settlements in order to maximize the network through the body plan. The process initiates from central areas where the branches expand in different directions according to arrivals. Connector units generate payment between seats to connect different body plans. After the settlement is connected, circulation units having 3 or more edge connections with their neighborhood update their state to shared units. Self-organizing settlement is formed by aggregation of housing units to the body plan. Throughout the settlement, we specified center units which are mainly used for the purpose of distribution of goods, depending either on land or on water. The units within the range provide users daily base support driven by supply units. Main distribution zones are located in centers where the network is highly densified. Since the organizational body plan is adaptive, we are introducing a sorting system which has an impact on body plan generation. It is based on disconnecting shared elements passing through daytime to nighttime, which are creating the expansion of the settlement. With the disconnection of shared units, the center unit will be activated in order to arrange the clusters within range. Reshuffling system is to maximize the connectivity of all the settlement. After all of these processes are done, the clusters connecting within the center unit, the branches will arrive into a state which are packed. We are using disconnected circulation units to connect the packed branches during the nighttime to have the general settlement of that period. After doing the sorting system with several branches, we can define the pattern into a more packed state, and it can limitate the expansion of the growth of the pattern.
Besides get food supply from land, each unit has its own sustainable strategy to feed itself. The first scenario is for fishing. Immigrants who want to do the fishing activities will activate the reshuffling strategies for branches that they are living. The branches will disconnect from the main body, with changing the body plan of it in order to adjust the fishing activities and also environment.
The second one is to introduce the educational mode as an external plugin to our system. Circulation units are gathering people from their housing units, which are in use of this educational mode, and then doing the reorganization of school or the educational units to generate the pattern. And for the orientation of the people, we are using ground units to support and light up the ways through the center area so that people can orient it in right directions.
Escape intend to interfere the suspended states between land and sea by providing self-organized, agent-based water urbanism. It is an alternative strategy for existing problems of housing. It is a temporary in-between new territory formed by semi-autonomous water infrastructures and sorting system. Tiny system that has capacity to create reconfigurable space or further opportunity for users to experience 24 hours life cycle. Meanwhile, different kind of activities and infrastructure to augment the key elements of water urbanism which are supported by the formation of tiling. We believe that the method of intervention to mass migration is this kind of deployable decision-making systems which are coupled up with human requirements and human-based agency.
Thank you.
Thanks, guys. I think why don't you just leave up either your trailer or something so that it serves as a background to the conversation.
I think Patrick, you're mute. Oh, no.
Yeah, no, I'm muted. Sorry. I'm not picking that off. Let's. But I have stuff to say later.
I can jump in if you want.
Yeah.
Well, first of all, I mean, you know, my mind is sort of filtering a lot of principles in there, really. And the idea that the majority of forced displaced people come from maybe 3 countries there in the Mediterranean. And the Mediterranean is one of the most beautiful places on the planet. And it's relatively stable as a sort of an internal sea, if you like, has great nutrition. It's almost like a mini Eden. And I just like the idea that marginalized people who are forced out of their homes through, you know, warfare and so on, by basically 2 or 3 countries in the world who are nowhere near that region, pushing those poor people out and put them into a level of misery as they see that their migration is a terrestrial event. I think reconsidering the idea that those people are not marginalized, that you put them into a situation which is really beautiful. I mean, incredible, the advanced beyond anything that you might even experience in a city. And with that coming access to incredible food, you know, algae, obviously fish stocks, blah, 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 blah. Also the way that you can use new energy systems to, you know, aquatic energy systems to be completely off-grid and autonomous. I mean, I think that's incredible, really do. And also the fact that, you know, they always say it shouldn't be called the Earth, it should be called the ocean because of, you know, the Earth is 70% ocean. And so I like that shift. So that's the positive side. I mean, the last thing you want is to end up with a Kevin Costner Waterworld scenario, which is, it gets fairly anarchic and very hard to control. So I think there's a lot of factors there because you're basically establishing a whole new society, you know, offshore in a way. But so how do you deal with that? And I don't know, I just feel that the solution, I mean, it's interested in its sort of tectonics, the way it's a pixelated proposal. But as always, I mean, it's, you know, it's what I like about the project is it's between industrial design, which is what I'm involved in, and architecture. And so it's a form of product that, you know, like the containers, it's a product. And I think the idea of dislocating that and going in deep into how you would really feel living there, because it doesn't take into any account a storm or anything really going wrong there. So I feel that there's a whole new missing chapter that you could look at, which is the sort of almost the biological way that you could look at structure and materials. It's good, it's very nice, so it's very engaging, but you know, you've got everything there. You've got solar, wind, you got the whole lot. And I think this could be a whole new model. You know, instead of dealing with the pollution that you seem to have in, you know, in the way cities are today and the way it's going, you just get away from all that. You make it a kind of, it's a utopia. It could be very real. I mean, it'd be amazing to, I don't know how you model it up and try it out. But yeah, I just feel as if, I remember years ago sitting in, I think Patrick was there in Vienna, and there was a project which was looking at space architecture. And there was one big thing that I realized, it was with Greg Lynn, and one thing I realized is that, you know, there's no orientation. The moment you take orientation out, you know, you have no datums. And I thought that was incredible, the fact that you could stand and be in any way. And I think to a certain extent, that's exactly the same with the oceanic concept. So yeah, I've got other details here which I can talk about, but maybe somebody else could just step in. Yeah.
Well, I mean, Ross, I always love your descriptions. They really lift the project further, and it makes me think of underwater exploitation when you're talking about the floating, the three-dimensionality, so I think there's an interesting opportunity which was perhaps missed in this case. But in terms of, I really think the project is quite beautiful. I mean, I was looking for the following. I love the amoeba and the way they open up, and the way they those shells kind of breathe and have open themselves to various directions, and how that correlates with the internal pumping of furniture. I mean, they obviously will need to. They're just a diagram in terms of the furniture. The piece itself has more credibility. What I'm missing is the following. I mean, except for the underwater, which you just came up with, is connecting up. I mean, a lot of the social spaces they're all outdoor space at the moment, and you have deep space, but only exterior deep space. So in the end, I think there was a very simple step which maybe can be actually added for the book. I feel that some larger indoor spaces mostly would be very good opportunities. So when these shells, maybe they slightly pull the weight in too much from the edge of the hexagon, or not, if they kind of connect up and make larger groups. Of course, there's also a question of the shell action on that, but I think that could be something which I feel will further differentiate the field, where you can see large, maybe then outside, maybe they have to go higher as well. Maybe another dome slips into the center and is grabbed by several around it. So I think that is something. I give you have it here in the diagram. It doesn't appear in the thing. And the second point was, I think was very important to see more of the interfacing with coastlines, with the rocks which crop out in the Mediterranean, maybe with a pier, with a boat, so that we're getting more of an interfacing into coastal geography, which isn't just infinite water.
Well, that's true, because after a while you would crave, because of our origins, you would crave land, but that could be
I see it more of an extension of land. And there should be some kind of, I mean, and I love, and the idea of fishing is great and so on, but I don't know if it was meant to be. It doesn't have to be. I mean, what I like is, the reconfiguration at the moment is only internally driven, and that's difficult to perceive. We just have to believe that there's a logic. But if there was a coastal formation and edges and protrusions, then you could actually visually perceive the adaptive capacity. And there is strategies of interfacing, nestling, capturing a land or tying up with land. Yeah.
Well, it makes me think about what is the economy of this settlement. I think you just got to think about that. How is money generated? How does it exist in that way? What is its relationship with the landmass? I mean, they're almost real jellyfish that kind of almost drift and scavenge, and and as we move away from a sort of a red meat-based culture, there's a lot of significance for me in this way of thinking that could in turn, recently during the lockdown, I've been looking a lot at space architecture and thinking about how you could bring that to Earth, because I mean, part of that is rather stupid, starting to think about living on Mars. There's as many negatives as positives. So, how do you bring this advancement, this technological advancement, back to Earth, but in a very, very synergistic, symbiotic way in terms of materials, forms, how we live in. There was a designer called Jack Fresno, and I was going to go to his 100th birthday about 5 years ago. I think he must have died because he can't be 105. But if you just check him out, he had all these visions. I mean, totally unknown, but incredible visions about how we would live with all the the physicalities that the Earth provides. So I think, yeah, I think you're right, Patrick. I think, what is that economy? How do you live with, you know, coastal locations? Because they're generally, you know, they're taken up by the wealthy. I mean, that's what the Mediterranean is all about. It's all wealth on the coast, you know. So yeah, I think that reversal of fortune is quite interesting politically. Yeah, can form an armada and invade Monaco.
Yeah.
Okay, that's all I got to say.
May I pick up on this?
I see that Suhar has her hand up, Veronica, if that's okay, and then you can pick it up right after, if that's all right. Suhar, are you there? I think you're muted. We can't hear you yet, Suhar. Okay, maybe as Suhar is sorting that out, Veronica, maybe you can start.
Yeah, I just really would like to continue with Ross's review, because I completely echo that it's an incredibly inspiringly and beautiful and empathetic project, and I'm wondering about this experience of this water landscape and living on water. And while I was looking at the imagery and hearing the narration, that I'm wondering, what is the connection with water here, and could it be developed further? Whether water could actuate certain processes. I think the notion of this kind of, as was said, these aquatic energy systems, completely off-grid and autonomous, I think there's a lot of potential here. But I also noticed that what was mentioned was this kind of semi-autonomous living space, and I'm really wondering how to push the boundaries of this kind of what is semi-autonomous or fully autonomous, and what does it mean to establish this kind of offshore population, as was said. So the questions for me revolve around this self-sufficiency. For instance, what about waste treatment? And also in terms of energy production and waste treatment, could we look at like the microbial conditions of the water things like microbial fuel cells pop into mind, or could this infrastructure that is established here kind of derive from this kind of bio-based microbial culture? Above water, I'm also wondering about the weather conditions. That how does this structure? What is its capacity to respond to different weather conditions? And maybe that is also connected to the materiality of this aggregation of units and generation body plan. So I think the settlement configuration has been beautifully thought out and then reflected, and it's now only to go beyond with the other aspects of what this project could be about, and how far could we really take it further in terms of materiality, looking at water as actuator, responding to weather conditions, and operability of space, of course, as well, as was already said. So thanks.
Thank you, Veronica.
I can jump in quickly to add a few more comments.
Of course.
Yeah. So I think most of the comments I totally agree. I was same as Ross, sort of charmed by this sort of more scale of product. I just kept on thinking that even though this came from the idea of being bound to community in water, you know, if we could get that sort of magical, intelligent material to adapt. I think that will not only solve that condition, but will living in the moment that we're now, that would something that we will all want, I suppose, right? That we could reconfigure our living rooms, change the furniture, readapt it. I think that could be a beautiful and very charming thing to have, right? And then I think, but going back to the aspect of community living that this will create, I mean, I agree with Patrick. I think that's where I find that the scheme remains a bit too singular in the way that the shell conditions developed, right? I think, yes, you show the clustering of how they could form a slight larger shell condition, but I think a community would require much more reinvention of activity, of program, as you mentioned, fishing and other activities. And I think that's where I feel it falls out a bit short in the research of how could these shells and these configurations will help create new communities, could help create new ways of living, right, that will adapt to these conditions. That's where I would have wanted to see a bit more variation or exploration on the system that could take on and mutate further, a bit like the floor mutate, that the shells could also become more than what it looks like to be just open structures, to really become different conditions of inhabiting this new way of living, right? I think those will be my points to add. I think all the rest is very nicely done. You know, I think it has very good geometric characteristics and principles are coherent. I think as Veronica mentioned, the environmental aspects and reality are still left to the side, but I think if we go with this, I think it's quite a charming scheme. Yeah?
If I may add my comments, unless we're waiting for Zuhairi. Shall I go ahead?
No, go for it.
Okay. Well, basically, I think there is something really excellent about considering this the sort of an adaptive settlement in water. Water is such an excellent landscape to allow for adaptation and to respond to the constantly changing conditions and needs of the number of migrated populations. And there can be so much that can allow that can be allowed in the interface with water, both from a resource level, but also from a level of connectivity. And that just the context of this really is really exciting. I think one interesting element is to consider the element of control. We talk about sort of a control system and semi-autonomous system, and just from a humanitarian aspect, I've come to, in the interface with refugees coming to Greece, I've come to experience that from speaking to them, that a large element of anguish is really this lack of control, this sense of complete dependence on the surrounding society and infrastructure, on supplies, complete dependence on the process, not knowing sort of how long they will stay in a settlement, whether getting reconnected with the rest of the family. And this lack of control is also interesting to see in the system of when we talk about semi-autonomous. I think it's interesting to explore. And Ross, you talked about a new society and how does that society, you raised that question, how does that society operate? And I think the society is both within the migrant population, but also the social interface with the existing sort of the coastal population and the population who they interface with for supply and aid, but also in terms of the society and the interaction with the centralized control system. So I think it's interesting to understand really when we talk about semi-autonomous, what is the balance, and how do you balance what happens as a centralized control, and how these cells are going to organize, and where do we allow a human agent sort of control system where it's human driven and human actuated. And there's really so much opportunity here, and there's opportunity for really creating more, building opportunity for more a sense of more independent living versus sort of this completely dependent, where you're dependent on the supply units, and these supplies are coming from the coast. But you touched upon fishing, but also just independent living in terms of connectivity, in terms of arrangement. But it'd be interesting to understand the dynamics and how do you balance what is a centralized, how the arrangement happens from a centralized control manner and a human-driven from the inhabitants of these communities. Also, it's interesting to consider the it was touched upon the interface with the land, and also sort of a sense of progression, and whether these settlements can be seen as something which exists both on water and in land as a more of a seamless continuation. That basically there's so much uncertainty for the migrated population of how long they stay in one location, and it's interesting to give them that opportunity and sense of progression in their inhabitants, and where that can take them in the stage of finding sort of reaching what they feel will be a long-term settlement or long-term position in the process as they migrate, and also creating more opportunities for interface with the populations in the country that they have arrived, to not really feel as an isolated community. And yeah, so I think, you know, we touched upon a lot as well considerations about seasons, about weather conditions, about, you know, I experienced it firsthand in Greece. A lot of the summer camps were used for refugee camps, which was excellent when refugees and migrant population were arriving during the summer. But when winter came, there was no infrastructure for heating enough, and these shelters were really not suitable. So it's really, I think there's so much opportunity to look at how the water and the water landscape can allow for in the interface, can allow for energy, water supply distribution, for food supply, for fishing. You know, we talked about fuel cells for energy, and really create these opportunities for independence for these populations. I think that there's a lot of richness there to explore, but definitely the adaptability of it is really, really exciting. Adaptability.
Okay, can you guys hear me now?
Yes, sir, we hear you.
Okay, hi everybody, and yeah, it was beautiful. Thank you for sharing that. I don't need to add much to the comments on the design. My question is going to be around context. I think that it's amazing to create a solution that seems to work on the outside for a particular population or group of people, but I think it would be really important to understand what refugees in general want or need. You're creating another no man's land for them, of giving them the best, sort of the most interesting, the most advanced sort of architectural experience where anybody else gets it. You know, are they feeling isolated and pushed out? So that's something to consider in terms of, you know, what does it mean to design a space for a group of individuals that we don't actually understand? I know some of the people on this call have worked with refugees in the past. The other thing is, of course, just the cultural context of how this is designed. I love that it's responsive, it can shift, it can be used for multiple purposes. But again, you know, if you think about people who are displaced or moving from one environment to another, what are they actually seeking? And would it be an incredible modular design or something that feels different? So again, something to think about in terms of, you know, what is the context for the spaces that you're creating and the people that are going to occupy these? And what is a way of thinking about more than just the physical space, but actually how you integrate them into this new experience and this new world, to appreciate it, but also to feel like they're participating and part of it in some way or the other. And, you know, of course, there's so much to think about in terms of how that's possible. And then finally, my question was around how long people are expected to stay here. You know, things are moving in and out, so clearly there's some mobility. But, you know, is this designed for people to stay forever? It's obviously a temporary space. How long can someone stay isolated in the middle of the ocean without going crazy? Or how would you address that with the design and how you think about it? So just some things to think about, but overall it's beautiful. Thank you for sharing.
Suhair, that was very nice what you said, and it made me it made me think, if I can just share these last thoughts. I see it very anthropological. So I have thoughts which are about human migration out of Africa, how we walked out of Africa, we went into the Yemen, the Middle East, and then, basically colonized the world over a period of time. And I was just thinking, there's a whole genetic thing going on here. Some years ago, I met Craig Venter, who mapped the human genome. He was the one that first did that. And I said, oh, what are you going to do next? He said, oh, I'm going to go on my yacht. I said, well, it's been a lot of work. I mean, you need a break. And he said, no. He said, no, I'm going on my yacht because basically I'm going to take samples across all the oceans, because he thinks that the oceans are full of DNA. So I'm just wondering what would happen. I'm really going far into the future now. I'm just thinking what would happen if, we were terrestrial creatures living in caves, going into camps, blah, 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 blah. You see this incredible future evolution of humanity, and the shift from land to ocean. And then what is that hybridization? So if you put a time element into this, I mean, in a sense, for me as a project, I would keep it very open. I wouldn't get into designing the furniture because I find that too facile. I think, given the big picture of what this could represent, I would get into all those things like genetic speculation. How will humans transform? Through satellite technologies and all of those things which work so well in this situation, because it's a very pure, visible idea. And I would see, I think in the future there's going to be, I don't know what percentage of people on Earth will be migrants, but it's through global warming and all these other things. I mean, this is going to become a ongoing condition, not only through warfare or conflict, but, conflict with nature. So, I mean, I think getting it back into an anthropological situation would open it up again.
Yeah, I mean, I think that this is the right kind of conversation to have in terms of where agency resides, and really to look at the social scenarios that are happening. I think Suhair is bringing up a lot of points which I think are very important to consider. And I think part of considering that is to understand what motivates some of the project is really looking at the found condition where architects are really not involved at all. Mm-hmm. And to think about the problem, I think from a design place, which is more prototypical, to find solutions that could actually plug into economies of scale, where when we look at the numbers that are actually displaced, and we look at the circumstances and the social scenarios, particularly in the Mediterranean, of an influx of people that for social and political reasons don't actually have the agency to specify how long. Sometimes that's being dictated to them, and to try to make that a much more human thing. I think the ambition of the project is somehow to look at control that's not really top down, that allows for a certain form of agency to be localized, and the fishing scenario and so forth, and all of that is just really about trying to create mechanisms within systems that allow people to form communities. Obviously, trauma is also a huge part of this whole process, so having some connection to land and all of those things is obviously very important, but also one of the main issues with a lot of the migrants that were coming, for example, to islands like Kos, was the tension of the influx of a lot of population, not actually being able to somehow manage how all of those things are actually happening. And I think one way of dealing with this is to try to understand that if there is a way to use the water and the seafaring, and particularly in the Mediterranean, which has a long-standing vernacular with this kind of approach, that there's a way to make these durational aspects for what should be a temporary situation, but unfortunately becomes semi-permanent in most cases, into something that has a bit of an infrastructure where it allows families to come together, decision making to be much more neighborhood related, and that's why we're approaching it from a much more agent-based unitary model. So in some sense, it has some relationship to maybe how Buckminster Fuller was thinking about the housing crisis and looking at forms of production when we were looking at materials, textiles, aeroponics, in terms of food production, other things. Those things, I think, haven't been foregrounded, but I think it's important to think about and to somehow claim that space, which it is somewhere between product design and architecture.
Well, there's one thing there, Theo, which is really, I think, very key, and that is it's not impeded by the cost of land. You just take that whole idea away. It's a sort of democratization of space. So you take away land and you replace that with space. I think that's really beautiful.
Yeah, I think that's where I meant in terms of the sometimes the tension and the pressures on land can be mitigated, I think, if there is a strategy to deal with this. And I mean, the students did an analysis of how many people were coming to the different islands and so forth on the day rate. And there is such an aspect of uncertainty and latency where we felt that the way that we could contribute was to look at kind of models and strategic models of management, for example, that you see in things like the port system or like the Amazon warehouse, and to try to look for a model of architecture which is in between resource management systems, mobility systems, and somehow to think about that as an edge condition to make a more humane alternative model. At least that's the implication. I know that there are a lot of challenges and problems with a lot of the things, and I think that's where also the emphasis in terms of how we present, let's say, maybe more of the testimonies of people that are going through this process, where many of the research, I mean, many of the migrants, don't have destination as Greece and Mediterranean. I mean, this was just really the gateway into Europe. And instead of from our side to try to assume all of those things, was just to understand that time was variable and that, with certain degrees, there are permanence and other things necessary to be able to plug into the social and political aspects of allowing people to have as a human of the pathway in this kind of moment as possible, because a lot of those tin camps and systems that are existing also cost a lot of money, actually, strangely enough. In Los Angeles, for example, they were using it as a strategy for homeless shelters. And the actual cost of the city of Los Angeles was something like $100,000 per unit. And the cost skyrockets for very different reasons. And I think with a water strategy, we were thinking about ways of particularly in the Mediterranean, where, we don't have crazy environmental surges of water. It's quite passive as a water place, that it could be the possibility of a viable solution in this context. And I mean, I think it's the beginning of some of the things that we're doing, but we were just trying to identify a certain way of thinking of reorganization that can be internalized based on local social decisions, community-based decisions, but also not to look at these things individually, how large populations could self-organize and, for example, take a top-down self-organizing strategy if there is an impending, climactic issue in terms of a surge or bad weather or whatever. So it's really to think about control in a much more real-time way than something that is actually 100% prescriptive or something that tries to lock people into configurations. It was trying to recognize that. And I think that there is a lot to be said in terms of the modularity, in terms of standardization of a one solution fit, but I think they tried to augment that with a way that they connect between each other. And the tiling strategy in terms of the ground was a way to allow in some ways the capacity for people to be able to customize their space or to be in a position to be able to create space. At least that's the intention. Maybe this is now being pushed in a kind of high-tech strategy, but maybe that is not necessarily something that is piston actuated in these kind of technologies that are very mechanical. I think that the idea was much more about a soft body system and water propulsion and some of the things that the students kind of lightly touched, but the idea was to be much more elemental and much more connected to nature and resources, things that we were learning from a lot of the vernacular kind of architectures that we were looking at early in the research.
If I just may add one last comment here, I think it is definitely an excellent opportunity for agency and the inhabitant-driven agency. But also, I guess another element to consider is the interface on both sides, given that it is a stage, as you said, it could be a gateway for a final destination. We don't know the length of it, could be semi-permanent, but there's always going to be influx of new populations. There might be separation of families and trying to reconnect, and then outflow of populations from the habitation. So it's really interesting in the self-organizing dynamics. How do you consolidate the needs of the individual, the self or the agency that the individual has, or the family unit has, or a larger community has, and also how do you relate that to the centralized, a more centralized control system that is required to basically arrange the overall picture. So it's interesting just to consider those dynamics interfacing with each other and the influx and outflow of people.
Well, thank you. Thanks everyone for the comments. I think that there's a lot for the students to kind of take on board, and I think with the 2 weeks that they have to put forward their thesis final submission document, I think it's very meaningful to be able to get these different perspectives and in some way to have that also reflective in the way that the project is being communicated, and maybe some opportunities to discuss other scenarios and foreground maybe other opportunities. So, thanks very much, guys.
Thank you, guys.
We'll continue with the third project of our session.
Yes, Adel, can you please present?
Yes.
Thank you.
And this one is coming from Sajay and Alicia's studio. Whenever you guys are ready.
Yeah. You can see my screen, right?
Yes, we can see the screen.
Yeah. Okay.
Hello, everyone. My partners here are Hazel and Pavlos. My name is Sultan. We're Team Polis from the Nahmed Bouchan studio. Okay, so what we're aiming to achieve is participatory urbanism that is materially occupant aware, a master system and not a master plan that can be implemented regardless of location, that can help inhabitants of an urban fabric live in a place where they have a say in the goings on of their homes, offices, places of respite, and respect to the built environment. The triad of participatory urbanism, architectural geometry, and industrialized construction are paramount to achieving the end goal, achieving a sensitive urban fabric in which inhabitants can live, work, and play on their own terms. A game logic to achieve a larger collective space based off people's decisions is not a completely new idea, but so far it's been more constrained to the cyber world, or where we take the position of implementing a cyber physical game in which experimentation can occur without the risk and can be run many times over until a result acceptable by the majority of inhabitants is chosen and carried out in phases. A material-aware construction method that understands the constraints and advantages of the raw material and develops a system for processing and synthesizing a product in a mass-produced, mass-customizable way. It's also very important. Architectural geometry that encompasses spatial variety and the structural tectonic of timber that allows density and richness to be achieved in the urban fabric, along with the coherence of interconnected elements that create a unit of space.
Timber is one of the most traditional construction materials and has a key role to play on both sides of the net zero balance. The emerging field of timber construction is the focus of our design approach. It is increasingly a competing option given the high carbon footprint of cement and steel production, and the novel technological improvements that bolster its structural integrity, mixed with older master techniques, providing its malleability, making it an ideal choice for quick assembly and high customizable spatial topology. From prehistoric times, simple, light, temporary timber structures were suitable for shelter. Timber was an ideal construction material, having both tensile and compressive strength, a high strength to weight ratio, and easy workability. Timber gave its place to stones, and after that, concrete, steel, and glass came to the first floor of the material selection for construction. However, today, as the environmental cost of building with glass and steel becomes increasingly apparent, some architects, designers, and scientists are hailing timber as the building material of the future.
A project with a thesis that reflects much of what we want to achieve is the Quayside project by Sidewalk Labs, where ideas of malleability and density come together with mass timber as the main tectonic system. On a large scale, it's also clear to see that the malleability allowed by the project's kit of parts and modular structure is not really being taken advantage of by the inhabitants due to the centralized decision-making process that might alienate people from with their various needs. The central decision-making is being done by a Google-designed AI with the set goals to optimize different urban scale aspects of the fabric. While it can please a majority, we argue that the large section is still left out of the equation because of the finality and authority given to the AI without taking advantage of the wisdom of the crowd. The interchangeable kit of parts is also present here and allows for a lot of customization on smaller scales. However, it becomes more clear that the intention behind the project was to build using the same methods one would actually use for any other, not taking advantage of the new age fabrication technologies or considering the benefits or unique aspects of the material they're using.
From our perspective, we strongly believe that individuals' micromotives can generate collective macrobehaviors. Instead of using a pre-designed deterministic AI as Google did, in our case, we believe that humans can make their own decisions. To check this assumption of crowd wisdom, we use sharing models, which is a social agent model based in neighborhood similarity conditions. According to the Shelling's prediction model, people are more likely to move close to people that are similar to them. Augmenting the Schelling model with more social parameters, like the option of agents to move even if they are happy and the attraction of urban venues, we can set the model for each region and create a dynamical social system that is constantly searching for an equilibrium. So in the specific site of London, where we run the test, we can see that the crowd wisdom gives us a normal distribution, elements of self-organization, and not just a chaotic result.
We also take advantage here of basically new age construction methods within timber that involved high levels of customization and curvilinearity to kind of gain structural rigidity and to give variation within our spaces.
This is like this is the where we are comparing the metaverse versus physical world, which will be seen in the game platform.
Okay, we're located in Euston, so right around next to Euston Station and next to Regent's Park. The area is around it has a length of around 1.4 kilometers, so it's quite a substantial space in a central area. So basically, what we actually try to do is try to subdivide that area. We kind of explored strategies for the site by ways of connectivity and how different resolutions of connectivity can produce different results, and how variability of subdivision sizes don't really conform enough to the existing site in a meaningful way, even though they do give kind of the variability that we're actually looking for. So can you go to, yeah. So from there, we constrained and exercised to create perpendicularity and parallels within the grid, but still keeping the interconnectedness and subdivisions as much as possible. So kind of constraining it to the existing site so that the rules of the real world can kind of apply to that grid that we're creating. From there, we evaluated the options we had in terms of connectivity, entropy, and integration, and selected our base grid accordingly.
Yeah, as an urban strategy, we decided to keep the main connections we get from the analysis and leave the plot as a free space to give more freedom to the people. For the building height hierarchy, we decided to have a gradual decrease that starts from the existing commercial areas on the surrounding. After setting the height map, 3 stages of the building development applied. 2 different modes of game is designed. The first one is, which is the investor game, is a data-driven game mode that has technical information. And the second one is a citizen game that allows an urban experience for first-person player. The virtual reality platform called Decentraland allows users to have ability to create and monetize their content. When user buys a parcel in Decentraland, they permanently owns it. As a result, users on the platform have complete control over the land. The scenes are designed to allow interactive applications for developments. By that, it creates a fractional ownership, which is the idea of subdividing ownership into small tradable stocks shape our game logic.
We try to achieve variation within our urban fabric using different languages within timber. So different kinds of timber tectonic, each of which kind of achieve a different spatial aspect and are used for also structural reasons for span, for variation in section and the like.
The first architectural language is based on compression, with which, due to its great stacking ability, we can achieve mixed-use high-rise buildings, always following timber's height limitations. We created a full compression component using bended timber elements, which adapt and changes according to the voxel transformation and the local conditions. So using this set of parts, combined with the differentiated components, we can easily construct different units that adapt to local and global conditions. We can see here that even by having the same voxel, by changing the surrounding parameters, as the ground floor conditions, the sunlight orientation, or even the voxel neighbor conditions, the unit adapts to them, trying to maximize the spatial efficiency. So we start with a single genotype that, according to the site parameters, it creates different genotypes trying to fulfill users and materials needs. In terms of the vertical hierarchy, the components have 3 width levels that changes according to the height in order to maximize the load catchment. And we can see a typical building of the compression language. However, even if that language let us build vertically, it doesn't give us the opportunity of large spans, which are necessary inside an urban fabric, such as large amenities, markets, or even large commercial spaces. To hold these spaces, we are using different languages that give us the opportunity, this opportunity. So initially, we started creating a fully tensile shell structure that could give us this span. However, through the process, we realized that if we mirror this, would give us a fully compressive shell language. So created this 6 shell components. As these components aggregate, they merge with the surroundings and adapt. So by the end of the aggregation, the components create a single cell. And that's the typical interior of the cell section.
Yeah, so this is basically a delamination system, a modular system connecting to a minimum of 3 to 8 points, 3 of 8 points within a voxel structure to create a varied skeletal construction. Then is accommodated by a one-to-one surface connection to be able to stack and subdivide space that is then interconnected within the structure. Then we kind of mismatch those surfaces as surface connections to create intermediate spaces and connections and openings within configurations to further develop them. The plethora of variations and compactness lends itself to the idea of dense urban living, giving it a secure niche within urban timber language. Aggregation is done by adding the minimum units of space with different edge kind of condition connections. Then melding the attached surface language to one another to create opening and to create continuity of surface. There you go. And these are kind of chunks of that language.
Yeah.
Using that same surface language for variation within a high-rise configuration is also important due to limitations of circulation within the groundscape version. The language wraps itself around a basic diagram of these game assets in a way that allows for similar sectional variation with around a rigid structural core. So these are essentially these pieces within variations, and then this is sort of the adaptation of those pieces towards the rigid core that actually carries it structurally and allows for that sectional variation to happen. The initial game asset is a 24 by 24 by 12 meter piece, a 4-story micro neighborhood with a mix of functions and differences in height. The interplay between assets creates variation in length and connectivity, bridging between assets that rely on proximity, overlap, and functional similarity between the pieces.
As we mentioned earlier, our urban strategy relies on the gaming platform. As the user launched the game, they have 2 options to select, and this is the investor game mode. Everyone, small or large, can become an investor and identify an investment area. Therefore, instead of buying large parcels, they can invest on more local scale. When investors start the game, as they select the assets from the design library and place them on the grid, they can decide on the use of the building, such as residential, retail, and public. By seeing the moves of the previous players, following this, they can also select the tectonic language of their assets. But there is one rule that they need to follow. They cannot place the different language on top of the already placed architectural geometry, but they can create an add-on on it. And there is this is like a feature of the game, which is like a connection between citizens game and the investors game. So in here, in the observation mode, the investors can observe the decisions that the citizens applied on their game mode. And this is like creating a feedback loop between citizens and investors game mode. Yes. Okay, yeah. As we move into the citizen game, it is designed to more often experience-based game mode, as it can be seen in the interface. As the players launch to the game, they will initially be informed about the current events and the rating of the buildings, meanings, likes, and dislikes. The main feature of the game is to offer a virtual experience to the user and able to contribute urban decision-making system. Citizens can contribute by liking, disliking, or commenting on investments. They can join events, as highlighted by red, or they can do shopping, see concert, and more. They can even save an event for later, and they can save event for later. Moreover, Moreover, they can visit a building, and yeah, you will see in seconds. Yeah. And yeah, I just want to mention the interface. Yes, like they can the feature is like liking or disliking, bidding, or leaving the reading the comments of the previous players. The game is basically offers them a negotiation platform that the citizens can directly buy a stock or bid on them. So overall, both games can in both games. Anyone can become an investor, or anyone can become a participant on decision-making system. And this is like then view of the, let's say, the piano event that can be held in the virtual world that we are offering.
Furthermore, residents are able to customize and see in real time their own spaces. Through the configurator, citizens are able to decide the arrangement and the materials of their house. First, they are able to select the spatial organization of their space through a catalog of different arrangements And after that, scrolling through some preset swatches, they are able to decide for the material. While they can also go on edit mode and start customize each interior element one by one, so they can create their own unique and personalized outcomes.
Our different languages need specialized production lines to efficiently produce and customize the pieces in an expedient way to maximize variability. So each of those actually could be initially fabricated on site to create certain things, but then when things actually ramp up in later phases, most likely what we'd actually be having is production lines off-site, where you actually produce at a much larger scale, but then customizability of those pieces and how they interconnect with one another would then happen on site with the previous existing space that we were using in the earlier phases. And this is kind of a video of how we envision that beginning to be.
This is all from us. Thank you for listening.
Thank you.
Thanks, guys. Could you guys, you have a trailer or something that you guys will leave on the slide for?
Yeah.
Okay, great. Okay, so we could start the conversation with whoever wants to jump in.
Yeah, I'm happy to say something. I think this has developed a lot from what we saw before Christmas, which I think is fantastic. I think there's still a little bit of well, I think on the most part, the construction sequencing, the gamification, it's all starting to look quite convincing. I think there's a little bit of work that can still be done in terms of feathering it all together. So, for instance, with the industrialized construction section at the end and the sequences that you go through there, can that somehow be linked back to the user experience of the game of defining your plots? Actually, can there be a more solid link between selecting a particular building type and then seeing what impact that has on the industrialized construction and on the factory? Does a factory need to expand if you start ordering more of a particular building type? I think it's that kind of cause and reaction that it would be quite interesting to see how that affects your kind of urban fabric. And also, I guess a question for you is, with the factory itself, is that, for clarity, is that located within this urban fabric or is it separate?
So probably initially, when first starting out with the project, probably you could have some construction happening on site, but then if things actually ramp up and many people are kind of buying into that urban fabric, you probably couldn't produce enough pieces fast enough with an on-site construction. So you would then convert whatever facility you were using in the beginning to just a customization facility, and you would have the pieces being produced off-site. So then however they connect with one another and with any kind of variability that you'd be creating within units of space that people actually own or inhabit, would they just come in already almost pre-done? Connection points between them would be only made on site and come together.
Okay. Veronica is raising her hand.
Yes, well, thank you for the presentation, and it's really rather intriguing, and it has somehow accumulated a lot of very, very interesting topics. of course, it resonates with two recent PhDs that were examined just recently here in Estonia by Siim Tuksem and Silla Pihlak, who were exploring the opportunities of timber modularity and timber construction. And of course, in Estonia, we have these prefab timber manufacturers kind of explosion, and we tend to be, I think, Europe's largest prefab timber solutions exporter or something. So we export to some 50 countries around the world. But that's that. So there are a lot of questions, of course, for me that revolve around this timber modularity and then the opportunities for prefab timber construction. But apart from that, I think a more, let's say, a more concerning question for me is actually what is a game in this project? How do you define a game? What is a game? And I'm wondering whether infrastructure, that what happens between these modules and then units, can infrastructure also be gamified somehow? And if so, then I'd be very keen to explore these kind of generated oddities that that are the side effect of such a game. And I would encourage you to critically ask yourself what can go wrong with such development, and how to then embrace these odd situations as opportunities for discoveries. I would also like to ask you, what is, in your view, the difference between an investor and a citizen? If you mentioned that the citizens are also owners of the units, so they're also investors in that way, and investors in their own living environment. So beyond that, as a citizen or investor in this case, I would be very, very keen to learn more about the decisions that I could make about amenities and services and facilities. And I already mentioned infrastructure. So yes, these are briefly my questions that came to my head. Thank you.
On a button briefly, I mean, in terms of the game structure, I really appreciate the hierarchy between the investor's game and the citizen game. Investor here, of course, has two subcomponents. You could have called it the developer's game, which is the entrepreneurial element, and then the investor would be the financial element, which could be separated, but maybe it's, you put them together, you mean the developer. And then you have the citizen, which is end user, who's, yeah, they're tenants bidding also for purchase. But intermediate for the office as well as for the retail in particular, you have obviously tenants that are not necessarily directly the end users. But anyway, it would become too complicated maybe. But you do have the third layer, which is the host, the master developer or planner. And that's what I think Veronica's question is also leading to. And you set up that game, but there isn't been the reflection of feeding back into that overall system setup and its flexibility of overall planning frame. So that at the moment remains kind of unreflected. I think the result is quite compelling. It's beautiful. It's a nice density and variety, and it's come a long way. So I do like also the unity across the different typologies in terms of tectonic and materiality, and also differentiation. So that works. But on the game side, I think it's great on the you explain the way the investor what choices are set up, and the way this citizen choices and interactions and experiencing. This is also an important element, including the configurative materials, and that there's a feedback. But again, reflect the let's call it the planner's scope, which you could also articulate into the public planning and then the master developer. But again, that could also be fused. That's basically who you know, the team is actually setting it up, and the setup system needs also feedback potentially.
Patrick, just coming onto your point about what is the game for all the people who are involved. I mean, the definition, if you base the whole thing around a localized factory production, that should give you immediately a great deal of versatility. I mean, whether that's the initial fit out or whether that's a retrofit, you know, look at where we all are now. We're all from home or wherever we are through a pandemic, and that changes the physical dynamic of where you live. I'm not saying that's going to happen again, but that's there are factors which come into play where a static environment needs to change. So having a factory on board is a really interesting idea. I mean, remembering that the main reason that 3D printing, additive technology was developed was for two factors. One was for submarines where they couldn't get a part, so they had to print something on board. And the second one was for embassies because of security. That's a fact. So this idea that a village as such has its own factory at whatever level, whatever they're dealing with, that then can create this incredible level of adaptation and change. I mean, just aesthetic change. Plus the fact that it could become a communal cooperative resource to sell out to, you know, other situations. So I would keep it local, and I would benefit from the idea that the factory is a very modern thing. It's not an archaic, dirty, fossil fueled thing. It's a really modern idea that can create augmentation or adaptation within the given site, you know, vertically, horizontally, and so on.
Yeah, I mean, just to come in on a bit on the game again. Sorry, was anyone? Yeah. Yeah. So like Alicia and I have been trying to kind of address and explore like this confluence between gaming technologies, like game platforms, and you know, game theoretic decision making frameworks, etc. And I think so. This team like really did open up like a few things for us, like in this first exploratory year. Chief amongst the discoveries are that, you know, they didn't speak much about it, but that idea that like private judgment can be converted into collective action through you know, either liking or disliking or so-called positive investment or negative investment into proposals that other citizen investors are making, etc. So that was one mechanism that like I thought like could have been explored much further. But like the fact that through your experiments, we kind of discovered that like is something that like we definitely will take forward into the next year. And the second, as Patrick mentioned, like any game to result in positive outcome, like for it to be effective resource utilization, etc., like requires a diversity of opinion. And I think in that sense, like having an investor hat on and having an end user hat on is like particularly important, so that it's not like an echo chamber of opinions that typically doesn't result in effective resource utilization. And the last bit also, like, which again you didn't talk much about, but you were trying to articulate through your description of Decentraland, is the idea of fractionalizing investment, so that like a large number of people can actually participate, can actually have skin in the game in a way, which typically now only institutional investors can invest in real estate. So these three aspects, I think, like for at least for me, was quite revealing and or discovery of those, and as means, as mechanisms to truly engage with the wisdom of the crowd. And I think like there, the distinction between the Google centrally planned AI versus a large participatory AI that you are proposing could have been like kind of further articulated and emphasized. So maybe at least that's what we're gonna definitely take from this project. And so in that sense, like we would commend you and also thank you for your effort.
One last thing I just wanted to say quickly was, if you take the idea of play quite literally, you know, if you see it, for example, to one side as a board game, you know, you have a designated footprint that's your volume. And I think if you were buying in to that, if the economics work well at its lowest density, so you buy in, then, for example, you could stack one building on top of another or have this form of mobility. It could mean that you could liberate space by lifting a building up and putting on top of another building. So basically, you increase the density, but according to the need of that community. That is a massive economic return. That is your return. And I don't think anybody's ever looked at that. The idea you could physically lift up a building, as they do with big construction. And because you're dealing with very lightweight materials anyway, and just pop it on top of another one. And then you've got this whole area that's liberated. I mean, wow. I mean, I just think that notion, I would buy into an idea like that as an investor, because I would optimize my return fivefold, easy. Quite interesting. And have a share in the factory.
There's one more thing we actually kind of wanted to focus on, since I don't think it was clear within our presentation, but what we also wanted to say is we have kind of two systems that actually kind of give input to the people that are actually constructing the urban fabric. So we have kind of a finished version like and dislike system. So the more, for instance, a finished building is liked, the kind of main developer that's responsible for that existing building is kind of given more power, more points, more influence within the game, within the urban fabric to produce and do more, and only gains more power as such. So kind of people that do, or developers that do what people dislike more, get kind of pushed away from that urban fabric. People, whoever does whatever people like more has more power and can produce more. So it's a cycle that actually lends itself to that kind of dense urban fabric that is listening to the what do you call it, the people that are actually inhabiting it. One more thing, other than the like and dislike system, the kind of investment system. So you actually do have an initial developer that's producing this, but then if you want, and other than just liking the building, you could actually buy in fractionally, as Shijai actually mentioned previously. So you can kind of own a percentage, a very, very small percentage or a larger percentage, depending on how much you actually want to invest in, to a building, to an infrastructure, to whatever that is. And then as someone else comes in and invests with you, kind of your stock within that kind of increases. It becomes worth more over time. So it kind of makes people want to be more involved within the game, and can benefit from actually choosing and investing in things that overall people like. So they kind of feed into each other from the larger scale and smaller scale, which is why we have the urban part of the game and the citizen part of the game.
But this fractional investing, do you see that as folded into the citizens game? Is it the citizens who are also meant to invest, or is it a third?
Yes, exactly.
Citizens. Okay, fair enough.
Maybe we can open it up to Suhair and to Nasia if they have some comments.
Then you have to watch out with their language. You call one thing investor game, and the citizen game is doing actually the financing. So
yeah,
developers and citizens.
We have it a bit mixed up. We haven't.
But idea-wise, I understand that the citizens, if you come with very small investment fractions, come in. That's interesting. Yeah, you back up your liking with a bit of commitment.
A bit of money.
That's also important, because otherwise, if you just the easy and cheap liking, disliking is penalizing developers, is maybe also not a perfect mechanism.
No, it's not. But it kind of is indicative of whoever is kind of doing a better job to those people, even before kind of consequences with money comes in. So it's coming, but you have a kind of you have feedback beforehand before you get screwed, essentially.
Yes, I think a lot has been covered already of the notes that I had, but mainly you know, it's such an interesting premise, and I think especially what you touch upon, this idea about micromotives creating a collective motives is definitely interesting. Considering the overall plan is something to be touched upon, but I think something really my key point in this was something Ross touched upon a lot, is really making the capacity for adaptation inherent in the system, both with the local fabrication, but also with things that are invested on, which are set up, that as usage happens and as these are experienced by the citizens, opinions change. What we like, what we dislike, how the overall plan, how things come together. So it's interesting to allow things that have already been constructed and built to actually adapt, to actually change, and for that input to be continuous, not just at the setup. And I think you touched upon it with the models, which are interesting, of citizens and investors, kind of those lines blurring, and investors and citizens being able to invest and basically enable developers that they like to do more, and the rest. But I think, yeah, really it's that adaptability and that tailoring capacity that exists at the onset, that is retained as the landscape is being built, and so that the overall infrastructure and the overall plan can keep being adapted with the input from the participants.
Exactly.
I can jump for a quick additional comment. I mean, it just there were two main things that I think everyone, and I agree with all the comments that came to my attention very quickly. I think the fabrication in timber, I think that's obviously a very relevant and very important topic, you know, and then how this becomes the overall configuration of the development. I think on one side it's very, as Patrick said, very coherent, very appealing, and it looks like a very pleasant space to be in. But I find that there is a bit of a disconnect about the fabrication on site, the modularity of the scheme, and then because suddenly I think it's explained quite well, the principles of fabrication, but then when you see it, it becomes too fast and too quickly, a more of a formal sort of elegant expression of it. And that, I think, that could tie into the comments of adaptability, right? Because if you don't read the elements of fabrication and modularity and change, right, I think it's harder to appreciate that this is indeed an adaptable system, right, that will be evolving with the game. And I think that will link the fabrication aspect being on site, that is a more of a live element that the game takes part of, and therefore the users could also bring in their intuition of understanding the fabrication process. The fabricators could really evolve more based on that intuition, right? I think those would be interesting elements to maybe expand a bit further, right? And I think the part that was a bit disappointing, I have to say, because everything is so well choreographed and coherent, is just the adaptability on the furniture. I think that remains just as a tick in the box, right? More like just choosing materials, you know, it's a nice design, but it doesn't really complement the scheme. So I think that's, you have to tick the box, you tick the box, right? But it's not something that is really exciting or coming strong, right? But overall, I think, thank you, it was quite good to see.
I think there's an opportunity for, as Paolo was saying, for like a second life. I mean, again, coming back to investment, you know, this factory has built what is basically a lined out box of an apartment, probably because it's factory built with everything in it, you know. If that was taken out and reconfigured or just put back together within another shell, that's another form of housing. That's something like a second phase. You pull it out, you sell it. You sell it as an apartment. And then you put it in a box, basically, and ship it out. You know, in the field of industrial design, we work with the basis of design for disassembly. So if you can put it together, you can take it apart. that's an ecological stance, which is ever more relevant, you know. And why shouldn't that be relevant to an architectonic debate? Absolutely, where there's a secondary use. I mean, there's such a skill base now across architecture, especially with AI and just the way that we have this kind of new intelligence where you can take something that has been built for one situation and then you just turn it into another. And, you know, I've been sitting on Brits for the AA for quite some time. And, you know, I remember the discussion about, okay, do we build an Olympic stadium? And what is the afterlife of an Olympic stadium? And is it a hospital? You know, what is the afterlife? So, you know, can these parts be sold on? I mean, a sheet of glass that's formed is worth a fortune. So why can't you sort of sell it on into another condition, like to build a school or to build something else? So it's not only a sort of habitable, typical social environment. There's another thing, a sort of afterlife for another scenario, which is keeping the residual value of the material and the technological investment in that material, retaining that. You know, you buy a car and the next day it's worth at least 30% less. I mean, it's a disgrace. Everything you buy, everything from a Dyson to whatever, which proves out the fact that, you know, products are made with a multiple of 5 times, 4 to 5 times. So you can just work out what something costs, what your Apple Watch would cost. You just divide it by 4, basically, and you will find out. So, I mean, it's a big discussion these days on how to retain the value, the mind value, the energy value, the fabrication value of objects. And that should relate wholeheartedly to architecture, because architecture by volume is incredible. I just bear that one in mind. And I think it's just about making kind of nice looking architecture. I think that the aesthetic would come out of a very logical way of looking at that. And it would still be beautiful.
I just like kind of think on that point, like just again, yeah, congratulations guys. I think that really like it was a very good effort on the last and what you have like done in terms of all the different aspects and the different layers of the project, from how it gets distributed and then built and the factory. I think definitely based on like agree with what all what has been said and the comments of like how these kind of production processes kind of like also kind of evolve as your city and as the different parts. I think that is a very rich position where you are now, where you can have these different facilities that can enable different parts, but then as the city kind of evolves and moves forward, how are these kind of processes also moving? And the other thing that, I mean, I think it just needs to be like kind of maybe further kind of clarified is what is the kind of relationship between the game part and like the kind of physical kind of building processes. So this kind of sequencing of like when one starts to affect the other, and then if the spaces get repurposed on the game, or if things start to be negotiated again on the game, then when will that kind of start to also be kind of affected when there is like kind of a build relationship? So I think that that's something that could start to enable all of these different changes between occupancies, but also between the different agencies. So some agents will be investors, but then maybe they are also citizens, and then they kind of also become have a different kind of hierarchy as they kind of own more or less, or kind of start to change their position also in relation to the other players. So I think that all of these like kind of hierarchies are something that can be very interesting and can start to add this other layer of evolution, not only a single kind of iteration, but like as the game kind of keeps evolving and different iterations happen and the players change their ranking or their position, even investors, or I mean, maybe like whatever other word you mean of the assets they own versus the assets they are lending. So I think that there is really a lot of room for like evolution, and I think it's just very exciting also like how these kind of also start to kind of become some kind of planning, or like really kind of be against all the current kind of top-down planning policies, but kind of become some really kind of bottom-up created kind of urbanism based on like the different agents. So I think that it's a very good job and a very good development of the project. And yeah, congratulations.
So I just wanted to make a couple of comments on, awesome. Actually, I think it's quite for limits and constraints. I'd be really interested in how you guys start to define the constraints around what can be physically built, what is possible, how many, how much can be built in a space. Are you building in anything that holds back kind of infinite construction or design? So that's something to consider. The second thing is around data. So obviously I'm very interested in the idea of what you described, sidewalk labs, generative design, generative architecture. And I think it would be very cool to think about how you could create a collective database and to see how decisions are evolving over time. I think everybody has mentioned this in some ways, that the way design shifts and changes is actually going to be manifesting into what the output is, and that's going to reflect what's happening with the community, what's happening obviously in terms of society, culture. And if that can be tracked, I think that will provide very interesting data for other populations, for dealing with problems, for interventions. But equally, I have a huge issue with the idea of the likes. I think you should really question that. Who's allowed to like what? Is everyone allowed to like? Does everyone have an equal vote in the likes? Are you using that data to do anything, to make decisions based on that? Is it owners versus citizens? Is it the moderator who comes in the middle? So I think before putting that out there, you should be quite thoughtful about what it means to have the like-in. You don't need to draw the obvious parallel to issues with likes on social media platforms. So really think carefully about how you structure that as an option, and if that actually feeds into the overall data collection that you have right now. And then the last thing is actually about the moderator. You should check out there's an app called Clubhouse where they've sort of you can kind of have moderators who show up and create their own little rooms and help to generate new kinds of conversations, but then they're participants by design. And I think there's something here around who is able to come in and impose structure, or is this kind of completely democratic citizen versus owner thing, or what is the role of the developer, as people have brought up over and over again. And then finally, I mean, you've obviously looked at Delve, which is the generative design app, app or platform launched by Sidewalk Labs, but I really think about how they are using data, what rules they're imposing on themselves, what constraints the population is feeding to this data, and how that is actually influencing their decision making. So they obviously built the city in Toronto. That didn't happen because they didn't ask anyone about it. But equally, as they use generative design to create new structures, how are they thinking about it? It might give you interesting ideas, or equally, you might have a lot more questions and more concerns around that.
Yeah, maybe if I can just complement maybe some of the conversations, and in particular, some of the issues that Ross brought up and some of the comments now that Zuhair is putting on the table. Because I think as I'm listening to the conversation, I think where intelligence resides is actually a critical component in terms of kind of enabling participation in a meaningful way. And I think somehow that's coupled in two forms. One is, I think, with the suggestion that there is a kind of local economy that somehow is helping to facilitate beyond the kind of so-called do-it-yourself kind of attitude that was kind of promoted, but really enabling, I think, a higher level of intelligence in terms of craft and building. And there are kind of examples of, mass production streams like Eames and, Prouvé and others who somehow were really trying to pioneer those kind of concepts. And I think if you take that thinking of a kind of digital craft with the idea of your gamification and think about the participatory aspect being pushed to its consequences, its extremes, it becomes interesting to see where you're comfortable with that. Because I think at one sense, there's a strong control in terms of the design language and vocabulary, which I think gives it a certain kind of coherence. I think there's been some conversation about furniture and then how much you could augment that. But in terms of participation, if it is about a co-designing and a co-evolution process, then I think through gaming, there's an opportunity to really educate and actually give people value by giving them agency in those decisions, which I agree with Suhair is very different than liking. And I think the intention to that, I think, is important to make, because actually, usually we are creatures of habit, and our response is sometimes when Sajid says the intelligence of the crowd, sometimes the intelligence of the crowd is actually immediacy and reactionary to something. It's not necessarily embedded with something that starts to give, I think, the ability to see the perspective or the multiple perspectives that, in some sense, maybe the gaming interface and the iterations of actually seeing consequences of decisions could have. So the kind of digital twin aspect and the versioning aspect to give more scenario-based ways of informing the general public, I think would be able to do two things: also educate the value that the built environment has and the impact that it has on the people that are living there, but I think also open up in a more participatory way beyond community design, when we're talking about things that in some sense are dealing with people's personal views on certain things, to think about social strategies that are really somehow embedded with actionable ways of seeing that manifest, and to understand that those things and those values hopefully are impacted by the architecture in a positive way and can evolve over time. So I see it beyond planning tool, and I think the real contribution will be in your assessment of where you see this. Like if you just take this now as a settlement or a portion, portion of London, and you just see it and evaluate the buildings and the organizations relative to others, if you're self-critical about it at that level, you would have to try to make clear distinctions about what you're contributing. But if you see these processes continuously changing and the adaptive nature of time being embedded, then I think we can really speak to the role that this will actually have, which I think is moving in parallel on a lot of different fronts. And I'm pleased to see you bring it to this level, but I would also think, like, at the same time, I would look at this and then be very also self-critical of some of the design decisions that were done around King's Cross and how those developments are actually did for certain portions of land, and just try to find a way to foreground some definitions in terms of how you see your development and your strategy evolve over time. I think it's beyond the building. I think it's really about interfacing and communication. And I obviously like some aspects of the design. I think it's resolved much more. But the one last thing that I just want to bring up, that the game is played on a board, right? Which is the kind of urban ground and the datum. And it's not really fully disclosed, but I feel like that sets up a lot of the rules of engagement without really critically looking at that. So the more that you can load to that initial ground condition with factors of the urban fabric, I think the more spatialized opportunities, maybe some of those initial moves will be made. And so I just think, think about how this thing will build its intelligence, and think about learning as a byproduct of gameplay would be my two suggestions to somehow bring this presentation, at least from my perspective, to a close. But I think it's been good progress, and there are a lot of issues for us to think about moving forward, and really where to place attention, not only in terms of the tools that we're using, but actually how we're working on some of these problems that are being identified through the work. So congratulations to you guys. And I think in a very interesting way, we're actually on time with 3 teams, 3 hours. We're very civilized these days, which is great to see. We're going to take a break for an hour and pick up the conversation at 4 o'clock for the critics that are coming back. I don't know if there's any concluding comments that anybody wants to make, but yeah, I think it's been a good first 3 projects to kick off another 3 sessions that we have for us. So I just want to thank the comments that we've received so far, and for the students for the presentations, because being mindful that they're presenting from all time zones across the world and everything else, just like all of us. So yeah, just my note from my side. We'll pick that up at 4 o'clock.
Also, thank you to all the critics from my side, for those who are not coming back. Please let's everybody be here back even 5 minutes before, so that we can have a sharp beginning, because timing needs to also be quite accurate in the second half.
Yeah, we're gonna
because some of us have commitments we need to go to. Unfortunately, couldn't be shifted. So let's be timely, and I've enjoyed this very much, and thanks to everybody.
Yeah, and yeah, I think we have 2 projects in the afternoon, in the second session, and yeah, it'll be continued with a keynote lecture for the critics that are not joining us by Albert Taylor Williamson, who's our lead technical tutor, and has been a long time colleague for 12 years, who's going to be talking about a lot of issues around design and engineering and placemaking. So we encourage everybody who's joining us to come back to it. So with that, we'll continue being civil and have a quick lunch or coffee or whatever is necessary, and we'll join back with the critics that are joining us in the afternoon session. And for those that are joining us tomorrow, we'll continue that conversation then. So thanks everybody. We'll talk shortly. Sorry, I'm getting messages through the door. Pierre, can you send the link to Rob?
Sure.
Yeah, of course.
Yeah.
Oh, Pierre. Okay. Yeah. I thought you said Peter, so yeah.
I'm not going to put you to work for that.
Hi, Peter.
Already put us
hi,
to
Ali. Nice to meet you.
Hey, hi, how are you?
Hi, thanks.
So it's been good.
I like your background. That's like a serious, like mafia background.
I'm actually concealing the clutter on the background.
Oh, really? You're actually in the space?
Yeah.
Yeah, that's great. I love it. Hey, Peter,
Yeah, sure.
I have to comment on the SIOC backgrounds, by the way. Those
You
are
like them?
They're crazy. Yeah, pink, fluorescent green. Like, what's going on, man? Fantastic. I'm glad you guys are into color. Hey, so how is LA, Peter? I mean, from the outside, it sounds horrible.
It's pretty terrible. It's pretty terrible. Yeah. No, it's terrible. But I hope things are going to start getting better. I mean, people finally, this vaccine rollout is totally a big confusion. It's ridiculous because we don't have a national healthcare system, right? So every county has its own rollout. So it's a mess. It's a mess.
Yeah.
It's going to take a while to get this back.
But have has California set up an app like in New York, and you can just scroll through and try and get appointments? I've been trying to do that every day.
It's a mess. Yeah, me too. It's a mess. It's a mess. Well, this rollout is ridiculous, right? It's so helter-skelter, right? Yeah. So New York, same problem?
Same problem. Not able to get an appointment.
Amazing.
I know.
Hey, Patrick, how are you
Hi,
doing?
good to see you guys.
Hey, great to see you. How are you, Patrick?
I'm good, I'm good. Actually, we had a super sharpening of the lockdown just from starting from today.
Oh, no.
If you walk out with permission, you get fined £200.
Wow.
You don't, something like that.
That's real money.
The rule is don't exit your house.
Not even in like going to get groceries?
Well, I mean, and they canceled all food delivery, only supermarket delivery.
Wow.
But I think you can go for essential supermarket shopping, but I'm not sure. It's pretty dire.
Wow.
Terrible.
Yeah, it's getting crisis point. It's the highest level of lockdown with so far in the whole year.
Ah, unbelievable. My LA friends are telling me that there are all these shanty towns that are emerging in everywhere, like in Beverly Hills, Venice Beach, everywhere. They're just all over the place, and that's breeding this huge spike. Is that true?
Not exactly, because actually for a long time, the homeless, well, there are lots of shanties everywhere. I'm in Venice, so they're all over the place here. But the reality is, because they live outside mostly, they had a very low rate of infection, actually, until very recently. Now it's starting to spike because they went indoors for the winter. But while they were living outdoors,
I see.
It was much lower. So I think it's got to do with them actually moving into shelters. And of course, those are just, impossible to control.
I see. Wow. Well, it sounds like it's bad everywhere, right? London seems like it's in bad shape, according to Patrick. Wow.
Yeah, it's tough. It's tough to stay fit, being kind of between the bed and desk. I mean, it's like,
exactly. Yeah, I know. It's quite difficult.
There's other forms of health implications for us, but anyway.
You got to get those virtual workouts monitored.
Yeah. Walking in a circle in my courtyard.
Exactly. A lot when you have
walk up on the staircase.
Well, we have the beach. The beach actually is still a pretty safe place to go because it's so big, right?
Yeah.
But other than that, yeah.
Guys, I think we have to kick off soon.
Yeah.
Because we have a tight schedule and we have these
cool
monumental projects which are so dense and big. So to look at them and discuss them is we had to allocate an hour each. So we have 2 intensive projects this afternoon.
Great.
Yeah,
We had 3 this morning already.
We'll be looking at 2 projects today. So one will be from Patrick and Pierre's studio. They're doing a large urban densification, co-authored urbanism strategy for Thames Gateway area. I'm keeping this super brief because I know Patrick has to run off, so I apologize if this is the short form version, but they've been looking at tower typologies primarily and looking at structural optimization strategies to look at high performance, analytical ways of thinking about evaluating design and coupling that with what we're calling social ecologies, trying to really look at systemic ways of kind of coupling social and, in this case, structural efficiencies and spatial deployment strategies. Alicia and Sajay have been working on gamification issues and looking at that within the domain of kind of participatory design, and that been tested out in kind of portions of London as kind of prototypical case study scenarios, looking at living, working, and other aspects in terms of who the game players would actually be, and what are the kinds of strategies between production, fabrication, and kind of time-based development strategies. And so you'll see 2 of those projects tomorrow. And the third studio is one that I run myself with Mustafa El Said and Apostolis Despotidis. We've been working on looking at post-disaster scenarios, particularly looking at control systems of land, sea, air, Amazon warehouse strategies. And you'll be looking at a project which is trying to augment the hospital system and trying to think about deployable self-organizing strategies that basically bring the hospital home, looking at health and well-being, and other ways of thinking about semi-autonomous and autonomous systems to be able to engage things. That's the really fast track overview. We've put together the mini site that I sent out to a lot of people, and the students and the live stream, they have all of that. They know all of the critics. We had a really good discussion in the morning, and I'm very happy with Patrick and the team that you guys are really here to join us to kind of continue the conversation. It's the first of what we are aiming to be a 3 to 4 year cycle on this. We've introduced more extensively, I think, gaming platforms as being part of the design methodology that we're sort of looking at it. So it's continuing, I think, a lot of the things that you guys are very familiar with, but at the same time trying to focus in on more durational, more kind of time-based ideas of scenario and planning, and to see the different kind of social and at times political aspects that are also kind of embedded within those things. So with that, I think maybe because of Patrick really needs to run off a little bit early, if it's okay, we'll open that up with the first presentation. Each of the projects is a thesis that they've been working on for about a year. And they have 2 weeks that they basically put together their final thesis documentation for submittal. So all of the comments that are going to be provided is kind of food for thought, and also a way for them to also foreground maybe some of the aspects that you guys are bringing to the table. We're really thankful that everyone is joining us. We know that the circumstances are not the easiest, but it's an opportunity really to see a lot of loved faces from people that we obviously admire and respect, and who kind of keep this conversation going within the program. And with that, I just thank everybody in advance, and hopefully after all of this and prior to Albert's keynote lecture tonight at 6:30, we can touch base a bit more. So with that, Pierre, if it's okay, just to launch one of the first.
You're going to see a new London, a new high-density multi-author London.
And as you can tell, the first project is Patrick's. So Hina, Martha, Ross, Ali, Peter, Rob, thank you guys so much for joining. Is the first team ready?
Yes, yes,
Yeah.
they're ready. Thank you.
Yeah, I will show the screen.
Yeah, and Pierre, if it's okay, put the microsite link in the chat just in case anybody wants to reference it.
Okay, will do.
Thank you.
Okay, can you see my screen?
Yes, I can hear your screen, guys, whenever you're ready.
Okay. Hello, everyone. We are the team VotePro from Patrick Studio. I'm Shanshan.
I'm Liyuan.
I'm Yeling.
I'm Wang.
Due to the shortage of urban land, high-rise structure become more and more prevalent. Besides, under the requirements of the network society, our productivity depends on participating in urban life. This productivity requires unprecedented levels of dense communication system provided in urban concentrations. To achieve such level of high density but avoid virtual charts of agglomeration, the principle of parametricing can provide a unifying base to accommodate the different forces that come into play. In addition to the urban fabric, the environment is also a key element. Flooding is a central factor affecting urban design. So we refer the strategy of a sporty city to achieve an ecological city system. We design specific urban strategy based on different levels: tower, base level, transition, and greening system. Porous structure permit the natural flow of water while they create a network of interconnected space. This structure becomes the three-dimensional connector between the urban and the architectural scales. We mainly use the sunlight to design the tower group and facade to get a positive effect on the environment and energy system. For wind, we consider its influence to the structure stability and the surrounding wind environment. According to the research, we can see the diversity of tower with the environmental influence. With different geometry of tower, the core and circulation is different. Additionally, we try to use atrium and bridge connection as strategy to get more accessibility and visibility between space. For the stability of the tower, we use topology optimization, which is an efficient system to analyze and optimize structure. Our project is located between the city of London and Canary Wharf. Our studio tried to simulate the potential for a multi-author urbanized that generates legible order and unity across a highly differentiated 3D urban fabric. We put the concept of unity and diversity into the project and designed this vertical city to adapt to change of urban and environmental factors. The tower are the main building structure of the city. The base level includes low-rise buildings and the primary traffic network, while the secondary traffic network adapted to the change of the natural environment and organize the greening area into the city.
We would like to show our project from 3 parts: tower design, urban design, and detailing. The first part is about tower design. We are going to talk about the tower strategy first. We consider 4 key elements: wind, vertical greening, topology optimization, and phenomenology. And we use 6 different strategies to design the towers. And the first one is based on wind. Based on the tower research in the video, we think about changing the curvature of the edge to reduce the influence of wind on the building. So we change the load which control the geometry in the mid. And for section, it could have different horizontal load to influence the geometry. At the same time, because of gradient wind, there are some changes of the grid of wind pressure. So combined with the test of wind currents, we can see where the grid changes, the wind flow changes more dramatically. So we choose this position to set follow to do further simulation. We use this kind of vertical load and wind load to get the basic geometry, and then use the follow to get the tower skeleton, including the exoskeleton and endoskeleton. And then use different basic volumes to do the simulation and get more towers. Those towers are always asymmetrical. The next two should, for more transformation, we use the section to test the 2D structure. The section flows are combined to create the 3-dimensional skeleton frame. And then we are mainly based on the topology optimization. One is to choose one basic volume as tower shape prototypes. The other one is to use some of them as basic structure, combine and do some transformation. We preset the location of several loads and supports in one basic unit, referring to several tops and bottoms of a cluster of towers. So we get those twisting volumes that are sometimes connecting and sometimes separating. Then we use those volumes as the prototype of the cluster tower shape. Additionally, we can also splice and mirror one single volumes to get left and right and down to get new structure and further to get new tower. Also, those basic structure and derivative structure can be spliced and connected with others. For the last one, as we mentioned before, we consider to design vertical grading into towers, which is always set on the roof or connection paths. So we set grading location on basic volumes and optimize the structure to get new towers. Then we're going to talk about the tower principle. We try to do deeper development of the tower, like horizontal structure, hanging elements, atrium, and facade. When design tower before, we focus on vertical structure. So for detailing, we try to explore the horizontal structure connection. And we choose the floor which set loads as structural layers and do the optimization. For the tower which has a skeleton and endoskeleton, this supporting structure could be used to connect them. And for the tower which only has a skeleton, we try to add some branching structure into towers. At the same time, we designed some other structure for this kind of tower. We did a research about the main building of HSBC in Hong Kong and consider to apply the truss in the tower as the structural layers. We test in 2D first, and then change and test different domains in 3D, get truss-like structure and apply it into the tower. And here the view in the truss structure layer. And for the floor, which has higher height, we want to design some removable floor to increase the diversity of space. According to the geometry of beam, we separated into different basic geometry and do structure simulation. And if the space is no longer enough in the future, we can add light wood boards to increase the space. And then about the atrium, it could be designed to 3 types according to the chain of internal structure. Additionally, we try to apply the porous space into atrium design. So we use stairs to connect different floors so that people have a variety of transportation paths and visual communications. In order to make effective use of the sunlight, we try to design different facades on the different parts of sunlight. We try to use dynamic facade on the part which always have most sunlight hours, and on the other side, we mostly use fixed facade and balconies. For the tower facade, we design fixed facade based on square grid, triangular grid, and linear grid first. And then the dynamic facade is also based on the different units. Additionally, we explore the relationship between facade, structure, and floor. When the facade is behind the structure, it can create balcony. When the facade can connect the floor and structure, interior space could be larger. And the last one is to use facade to cover the structure. For this one, we could use metal rods to connect facade and structure. And just taking one single tower as an example, we did a sunlight analysis and confirmed the location of different facades. And for dynamic facade, the panel moves left and right around the middle axis based on the sunlight. And here's a short video showing the dynamic facade, how it changes based on the sun exposure.
Next.
And because of geometry and position, different towers have different facade situation.
Then we think about the circulation system. We divide the vertical circulation into high rise, middle rise, and low rise, and set elevator accordingly, and add express elevator and skyview paths to improve efficiency. For the transform between different vertical circulation, horizontal circulation is set according to structure and height. Also, considering the connection of towers and transition, it is necessary to have elevators, ramp, and staircase to connect different levels of transition. There are several types of relationships of elevators with structure, sandwiched in between or isolated, attached to surface or embedded inside. And the elevator can be set in the atrium or outside with facade. Therefore, we designed several elevator nodes for the circulation according to the research. We also consider multiple combinations between elevators and columns, including straight columns and oblique columns. Except setting transform layer, we consider to design bridge as one kind of horizontal circulation. There are two main ways. One is to design the bridge as part of the tower. The other one is to design it as connection part. When designing the bridge individually, we simulated the structural test. Firstly, tested the bridge between the tower with same height, then change the height. With the result of tower distribution, the supporting structure is always a true structure extending upward from the tower structure. Then we get the similar result after the 3D structural test. This structure is like branches which mainly has thin points to connect the tower. Additionally, with the unit structural test, firstly, we tested a series of different volumes and tried different ways of adding load to get bridges. And so we will add loads changed from only vertical load to load that perpendicular to surface, and also add load on lines and add it on random points. We also got the other type of bridge, the substantial bridge, by setting supporting points on the corners and setting loads in the middle. We test and get the hanging structure. Then connect the bridge between towers. We divide them into three kinds based on the distance of the tower and the features of bridges. Then we connect the bridge between different individual towers. The top of the bridge is open green space, and we extended green into the interior space of the tower. At the same time, bottom part is mainly for public communication space.
Next.
This part is urban design. We did some research about our site, original function, main road, and traffic node.
Next.
Especially for flooding, we did the simulation to see how the times tide will affect our sites. It would be affected when the water level is higher than the usual range. We reserved the residential area along river and park in the middle of site, then got the main road and block by using the Woolly path. After that, considering the influence of flood erosion, we divided the site into three types. The area which is flood erosion most suited the porous dense network, which buffer the effects of flooding better, while the less erosion one will be the linear porous. In type A, the second level is on the center of dense area. The low-rise are beside the tower. While in type B, the transition is used as a low-rise and the second level is around the center. Besides, in type C, the whole transition will be used as fluctuating building. Going back to the Hoa site, we consider the secondary transport system which can connect the two parts of site and get the main road. Besides, based on the situation of erosion, we established the dense areas of porous and got the first level of transition. And then we consider the gathering area of pedestrians to have one more level of transition. In terms of the structure of transition, we set two main types. In porous dense network block, the structure will distribute under the transition, and in linear porous block, the transition and the low-rise building will share the support structure. This is how we build the structure of transition in the site. Next part is skyline and layout. We did some research about the skyline and concluded it into two types. One is unimodal with one highest tower and a more middle-rise building. The other one is multimodal with different heights groups of tower in the city. We try to design the skyline that people can see different types of trains from different views in London. There are two peaks of skyline around the site. Shard and Canary Wharf becomes the peak. We confirmed the location of the tower based on the transition and removed some small volumes. Then we used the secondary path we designed before to cut some large volumes and adjusted some volumes to get the massing layout. Combined with the skyline research, we simulated 8 kinds of layout and compared them. We choose one of them which has the diversity of skyline and also have suitable sun and wind environment. And combine with the site analysis before we determine the main function of each block. About grading system, we divided it into 3 levels to suit the transition. The ground level is more based on the flooding erosion situation. The erosion area will have more greening to filter.
The last part is the detailing. And the first one is about the building. We choose different kinds of tower and design the programming according to the structure. For the single tower, it always has one main function. And for the tower with bridge, it has the mixed functions. Bridges would be used as the sky lobby. Then adding the circulation system according to the structure and the programming of the different tower. We select the specific tower to do more detailing.
Next.
We apply the elevator, ramp, and stairs to be the vertical circulation. Atriums and void inside create porous space and improve the communication and visibility. We also design the different floor plan according to the programming of the tower. Here is the view of the office area. And the sky garden holding by the structure layer provides space for the communicating and relaxing. And here is the structure layer as well as the sky lobby. We can see how the facade changes with sunlight. Then we enter the tower where people use the circulatory system to achieve the different function space to work, communicate with others, or have a rest.
Next.
The complex tower consists of 3 main connect volumes. The bridges and the truss structure layer help to connection and horizontal circulation. We apply the hanging system inside, and it can be adjusted according to people's need. And the floor plan of different layers is set with the different functions, like commerce, exhibition, communication, and lobby. This is the view of how hanging system and removable floor apply inside. Here shows the scenes in the transform layer with the structure. Another view of the structure layer. And we decided to set the sky garden based on the sunlight analysis and the feature of the structure. It mainly located on the sunny side, holding directly by the truss structure layer and pocket by the cross structure in the corner. Here is the view of the sky garden, bringing greening into the tower. We can see the sky garden is mainly set on the structure layer. Then we designed the mid-side rise tower and the tower lower than the 150 meters to achieve more connection between tower and transition. We simulate the endoskeleton and exoskeleton and combine them together. Additionally, we add some balconies overhanging between the endoskeleton and exoskeleton to expand the space. We expect the circulation middle rise tower has a structure connection with transition, and some part of the link structure serve as a suspension structure for the second level transition. And at the same time, we design the vertical greening into the tower. For the low-rise one, we also optimize its structure. The roof of this low-rise could be used as garden, which would have the visual communication with people in the plaza on the ground floor. Then is the urban detailing. According to the design before, we complete the master plan of our project. We choose 3 typical blocks to show how the city works, which each type shows the different porosity and density. For the first one, the ground level shows the how to arrive to different tower. And on the first level, we can see the relationship between the transition and the tower, and some connect together and some become the atrium. And the second level is mainly used as the landscape plaza. We design different kinds of atrium in the tower and also apply different functions on the roof of the tower, such as the roof water harvesting, the sky garden, and the drum port. Transition connect different low level of tower with the base level of city. According to the position and the structure of tower, we use differently way to connect them with the transition to increase the diversity of the block and get different transport level for the people to use. So people will have more choices to continue daily activities when the flooding comes. When the flood goes into our site, we transfer urban activities to the transition and also use it to create the new landscape nodes. Additionally, we use the similar way to design the other blocks. This kind of block always has more individual towers which already have the connection part inside. And we can see the different traffic level in this block. And in this kind of block, low-rise building always use the tower structure as supporting structure. And this view shows the vertical relationship of ground level, transition, low-rise, and tower. And this kind of block is a bit special. Block 18 building is mainly used for the public activities. The main road is road block. And people could have the communication from park and the block 18 building. The main roads through and connect different blocks. And the people can also get into the roof of the block 18 building from the transition of other blocks. Except the road on the ground level, we also use the transition as secondary traffic network to connect different blocks. And here is the view from the London Bridge. The skyline has two peaks. When we look at the site from the Canary Wharf, it always would be the one single peak with the shard in the west, and it can create middle peak in the London.
Our project is a vertical city to adapt to the change of urban and environmental factors. It includes towers, transition, low-rise buildings, and base level. At the same time, we put greening into our design to achieve ecological city system. We try to design different kinds of towers, blocks, and connect them by circulation system to achieve the diversity and unity of the city. We choose one block to show how one person lives in the city. She starts the day from her home and use the transition to go to different functional towers to work and socialize with others. After that, she goes out and have a rest or do some outdoor activities. Then she goes to another office to have a conference with colleagues. After the meeting, she takes the elevator to the lobby and leaves this tower. Walking on the ground level and across the main road, she arrives at the entrance square of this office tower and goes up to the office floor, work until night. After finishing the work, she could enjoy some leisure activities. Maybe go out to some low-rise buildings for shopping, exhibition, and more public activities. She can also go to the outdoor square to socialize with others or enjoy some performance. Additionally, she can go to the band side to have the full view of our city. We can see the different connection between floors, buildings, and transitions, which could increase the diversity of city. Additionally, we design different outdoor landscape to provide more space for urban life. When she goes back to the residential tower, she can communicate with neighbors. Then go back her home and end the day. That's all. Thank you for listening.
Thank you, guys. So we'll open up the floor to comments now.
I have a question. You imagining this project to be built simultaneously, or is it phased? I mean, just coming back to some of the introductory comments that Theo made. Or was that given any thought for kind of the rollout of this design? Or is it really seen as an instant city
Sorry, can you explain again about your question?
The question is there, for example, you've designed this fantastic part of the city, right? Most cities develop over time, right? So you build a couple of buildings, and then once you've got a quadrant done, then another quadrant is built, etc. So have you given it some thought about how to actually manifest your fantastic idea on a city such as London?
Yeah, it's in London.
Frankly, we haven't discussed that. I mean, it's interesting. This is obviously something like was in Europe would probably be faced. In other parts of the world, not so much. Think about the kind of projects we've been engaged with several million square meter in one shot.
Yeah, but I'm just kind of focused on
there would be an element of that, of course.
Yeah,
How would one have multiple centers and grow outwards, or would you start from a center, single center, etc.? But
yeah, those are interesting issues, though, Patrick, right? Because if you have this kind of fantastic project, then the more the strategy of implementation is as important, if not even more important, than the actual design. You know what I mean? So it's just, that's why I was just wondering if
it's an interesting point. I mean, probably if you start with a cluster of 3 or 4 bridged up, then you get the experience, which is in a vertical urban district in its own right. But yeah, I mean, this is only a fourth of what the overall proposition suggests, because we're talking about 4 sites adjacent to each other, with each of them containing about 25 to 30 towns.
Well, I think that's I mean, it's an amazing presentation and project, but to continue on this line, I do think that the question about the rollout is a very interesting one to extend the discussion. That because it raises questions about the integration of infrastructure and architecture, that you could imagine, there are questions that integrating infrastructure and architecture raises that have to do with different rates of, let's say, technological development and change and investment and so on. It raises a lot of very, problems that are probably beyond the scope of this investigation, but nevertheless could inform further development and maybe challenge some assumptions that have to do with that integration. So I'm just wondering about the thought of, to what degree can we integrate infrastructure and architecture in a project at this scale?
I mean, as you might know, I mean, this site next to Canada Water is a huge site which is under development by a single developer with I don't know, 20 towers or so. It's, of course, it's more residential. And the delay. London is meant to grow and is the fastest growing city in Europe, but the planning process is what's stopping things to move fast. I mean, we are sitting on a twin tower for 3.5 years now, but it's stuck in the political system. So, and there are 50 more such projects. So.
Yeah, it's interesting, Patrick, that you raised that, because even Hudson Yards, right? The developer started this amazing project, huge project, largest in the US. Yeah. And then halfway through, the politics shifted against them. So they're not allowed to build the second half. And now the Related Group, who you know very well, Greg Goucher just told me that it's going to take them 10 years to get out of that hole, as a company. It's because they're not allowed to build the residential projects at the other end of the site because they're too high end, right? So the criticism of this government, this mayor, has been that we need kind of a more affordable housing, and how can you build all of this? So these are kinds of issues which are interesting to think about in a proposal such as this. Are there ways of camouflaging development? So are there ways of thinking about how these might develop into kind of more robust strategies? And I think they're all embedded in a funny way. So it would be just interesting to have them think about that a little bit. Anyway.
It's an interesting point, Ali. I guess the question is whether or not like, I mean, it's an amazing scheme. I wonder whether the scheme actually has to be a single developer, because, I mean, I think one of the great things about this scheme is if you compare it to what's across the water, you have Isle of Dogs, which is a very messy kind of hodgepodge of things that have been developed by different people. And it has a very conservative approach to water with the canal and things like that. And this scheme obviously takes a much more interesting approach to both the master planning, building design. There's some kind of coherence and order between it all. It's considered with a lot of environmental factors, and even the flooding. The relationship to the water, I think, is also very creative relative to the Thames Gateway, and the fact that the Thames actually is a water body that does change level quite a bit. But I don't think it has to be a single developer to pull it off. Of course, that's the safest way to go about it, is that you have one management centralized kind of control of a site like that. But it could also be done through an architectural scale master plan, where like a lot of this has been kind of, a lot of the design seems to have been working with things like topological structural optimization. There's a number of principles at play that could just form part of a more elaborate 3D master plan, perhaps. Yeah, really.
Yeah, it doesn't rely on the particulars. All it's required is a certain paradigm of developing, which is always to look for these shared environmental forces to generate a shared kind of physiognomy in all the differentiation, which is then still within its possibility, to look for affiliations, connections, the ethos of participating in the fabric. And the whole point here is this multi-author, and that could also very much be multi-developer. But presuming, the one unrealistic presumption is that they all work from a contemporary paradigm rather than being stuck in retro ideas.
Yeah, that's a good point, Patrick. I mean, yeah. I'm just thinking, I'm just thinking that what if, okay, if you just look at this urban form, right, from the outside. I mean, I love the investigation, and I think it's very sophisticated. They know the techniques backwards, they know, and we can get into the building design later, but I just want to talk about the overall urban form. I think that what's interesting about kind of a normative developer trying to maximize square footage or square meters, right, in their development, with that, it would formulate a sort of resistance to the incredibly sophisticated aesthetics of the project, right? So if you look at the overall form, what I mean by that is that the buildings would begin to have individual identities relative to the urban form. Currently, if you look at the project from afar, it really looks like a sort of a singular object in a funny way. And so the differentiations are definitely there building to building, but it still looks like it's a contemporary version of say a social housing project in New York in the 70s. You know what I mean? Where it's rolled out in all of its relationships and nothing is dialed back into resisting it. So what I'm saying, I don't think I'm not trying to make it negative. I'm just trying to say that that's one approach that's giving this project an overall form. It's actually not an urban project. When they zoom out onto that master plan view or the skyline view, it looks like one big building that's been developed on this area of London, which is a strength, can be a strength, and can also be a weakness. So it just depends on how the students present it in a funny way, right? If that's an advantage, or if the singular resistive towers would give more identity to these really finesse geometries that are derived from the algorithm.
I mean, I think you're hitting on the core issues which we're trying to test out. So in these distance views where the white skeleton always predominates, and you lose the sense of differentiation, the different types of structures and skeletons, the different types of towers, that becomes too homogeneous. And the problem is partly in that the big model doesn't carry all the detail, where you have those towers where the facade is in front and becomes more curtain wall with the see-through. Other sides there's louvers and balconies protruding, and on the back sides it's more no shading. And then one could have and should have had further stronger differentiation, the programmatic stratification, which is thought through. Yes, there is an issue where at the moment it errs on the side of homogeneity. Other teams had pushed further the differentiation in materiality, concrete, steel, timber, etc. And that's been the attempt. Last time we had the presentation, there was a sense of lack of unity. It became too collage. So to find that balance and make something rich and diverse, and that you recognize the variety and individuality of sub-districts, but also you have a sense of an overall identity the towers participated, district identity and overall identity. So that's the interesting one. And I think if you look at all the 4 projects together, you get, of course, more diversity, but yet you still have the unity of paradigm. And that's an interesting view. I don't know, this wasn't included here, but we actually created a single rendering of all 4 projects, which is even much bigger. It's the whole zone between City of London and Canary Wharf. And then you can see Canary Wharf is at one kind of homogeneous, a single hand designed nearly, it's in its core kind of axial thing. And then the City of London is that horrendous, menacing pile of unrelated pieces. And this is meant to be some kind of organically differentiated and new district which ties it together. So that's the dials we're operating in this project, and in 4 different projects with 4 different degrees of emphasis on differentiation versus unity.
That's fascinating. It's fascinating as a collective research body,
and
right?
There's of course many more dimensions, where one could have also in terms of the tower proportions and scale, they're relatively homogeneous here, etc. It's an interesting one, very interesting one.
This is a really interesting question for sure, because first of all, there's a great, one always wants a degree of coherency, and this project has certainly got a tremendous amount of coherency, right? Which one wants and demands from a project, and one feels very excited by. The model, I think it's a very comprehensive presentation. I really particularly like the models that are sort of midway up through the building and the detail of the different layers of the project. You guys have done an excellent job of, really combining the layers where one doesn't feel like any of the pieces can come apart. It's a very coherence. It's coherent at the level of the building. And then there's a coherency. And I think what is being discussed is whether there's too much coherency at the overall that needs to loosen up perhaps at that level. But all to say, this is a very comprehensive project. I think to come back to this question of density, which I think that started in the beginning, when I first thought about, look at how much square footage we're dealing with here. Is this at a time when we're trying to de-densify urban life? Is this something that, has legs as a potential question? And I think you've done a good job of tying it into the ecological, or tying it into questions that begin to, make us result where I don't feel like there's an overall dense, it's too dense, right? But there is a potential in sort of looking at the question of whether one wants to lose that coherency at the overall, that one could play a little bit more with the density idea that you originally started with. At the moment, the density seems pretty even, right? The towers, the program, how you're looking at it. I think you've got all the ingredients and the formula and the rules. But now you could begin to sort of take this initial idea of density, and by densifying more program, like if you go to your program diagram, and I don't think we need to, but I do remember seeing a cut through where it struck me as a very traditional way of programming, right? You've got the urban, the hotel at the top, the residences all at the same level across the whole master plan. And there, I think you could have a really interesting possibility driven by an ecological driver that can help you densify certain areas, de-densify certain areas, use these same rules that would give you another reading, both at the level of the individual building and then at the level of the master plan. So that, just to say that could be another rethinking, perhaps. And only one other comment is that I love the ground level and the sub-ground level. And there is almost these voids, right, that are in between the buildings. And you've looked structurally so carefully at these bridges that go between each of the towers. I would just love the experience of the ground and sub-ground to continue up, because right now you're just, it comes back to this idea of density. Could some cluster together more to allow more of that experience on the ground level to come up at higher levels? It would be very exciting. So, but I think density could be your thesis to drive those questions.
Can I add something to this?
Yes, sure.
I think that following up on certain things that have already been said from Peter on the question of infrastructure, the domain of the single development versus the multiple development, I have to say that I really appreciate this idea of the porous podium that you have developed in the sense of how you related it to the water idea and the flood erosion. But I want to offer maybe a different reading of the project that maybe is possible, which is, in front of climate change, there is also certain cities that are beginning to see that when it rains a lot, or when there is like unexpected levels of water, then suddenly it is very important to collect the water and to release it slowly, so that you don't collapse the city infrastructure with the water that falls all in one go. And I think that if you could think about your podium as a major infrastructure for the city, as in a water collection and water management strategy for other places surrounding neighborhoods of London that are actually not prepared for the challenges that we have, the environmental challenges that we have now. So in that way, for instance, you could think of the podium as a municipal single development that would be then thought as an infrastructural movement, and therefore the design of your podium would very much respond to the necessities to collect water at a major scale of the city, as in to be a water reservoir, but not so much to keep the water, but to release it slowly. And in that way, for example, the towers could be seen as the other side, that maybe that would be a multiple development. And I think that in that respect, maybe the approach with topological optimization in terms of the design of the tower could be not seen as a kind of formal mechanism, but again a performative one, because I think it could be it's now common logic that these kind of approaches, like topological optimization, we also do from a sustainable perspective as a means to reduce the use of materials. So it could be very much a kind of almost like massing strategy, almost like a structural approach to different types of buildings, but that would encourage the use of structural optimization for multiple designs, multiple developments, etc. So I think that there is, if you think about it from the sustainable perspective, then the podium could be understood as a municipal infrastructure at a very, very large scale, and therefore very meaningful for the city. And the towers could be seen as a means to build with a perspective of reduction of the material consumption by different developers. That's all I can.
Sorry, Martha, I didn't want to cut you off. I'm going to connect a few of these comments. Where I get most excited by the project, where I think it's super tight, is this really exciting moment when you do all these cutaways and you see about 10 floors together or 4 floors, and you have these really tight relationships between the structure, the space, the floor slabs, the program. There's a lot of things that are kind of unified at that scale that show, I think, a strong affiliation between parts, but also they seem to sing together with a clear kind of both aesthetic and practical benefit that you just can't deny because it's all tight and it's working together. As soon as designers scale up to the whole building, extra complexities emerge, and then to the city, other complexities to emerge. And I think those start to demand different aesthetic questions and different practical questions. So, you know, like, what are the challenges that you face at the scale of a whole building compared to the chunk? One of them is that from a structural point of view, the loading, all the structural members at the ground floor need to be thicker to carry the dead weight of all the structure at the top floor. So suddenly something that works, say, and this is fantastic, these chunks, but when I look at that chunk in the whole building, I expect to see the structural members probably taper or get smaller as they go up. When you get to the urban master plan, I think it's a less clear problem. Like, what might change across the scale of a master plan? You know, at the scale of the building, we have something like structure where you have a clear gradient of loading. You know, towards the top, there's less loading than at the bottom. As soon as you get to a master plan, you know, you have site features and constraints, you have sunlight, you have the flooding, but suddenly there's no physical ordering that comes as naturally as there is in the section. And I think it's a big question I have is when we deal with these things, like you've tried to differentiate every building, there's been a discussion about whether they're too homogeneous or whether they're too different. Patrick was talking about the struggle between these. And I think we actually don't really have a really concrete way of dealing with this across the architectural discipline to be able to describe fully what are the problems that both at an aesthetic level and a pragmatic level that require an ordering beyond the scale of the building and beyond the infrastructural ordering. You know, like, so what are the kind of aesthetic criteria? What are the spatial, environmental criteria that one could evaluate things larger than the building? It's really difficult to do. And I'm talking about still in terms of architectural design. Of course, we have a whole discipline in urbanism, but
I mean, this is a very important point, and just to throw in the idea, for instance, what Hannah said. If you, for instance, differentiate densities more strongly, but you do it according to a principle like a gradient, with more density, you know, away from the river, for instance, in that layeredness, then you unify an urban order. While you have more differentiation, you actually have more order and unity at the same time. So that's the way I would use it. Similarly, if you'd emphasize more the kind of north-south differentiation, and that runs across the whole, you get more distinctness in each tower, but you get a unity across. So this has been the dialectics we've been searching, and on the urban order, and because it's not only a question of similitude and homogeneity versus differentiation, but it's a question about letting differentiation in an ordered sense, so that there is a complex order which becomes legible, precisely because it is a kind of strategic use and a non-random use of differentiation.
I think there could also be, though, a kind of beyond the aesthetics, there's also maybe tying into that, there's other things like Martha was talking about, the environmental factors. I mean,
absolutely, and I think that is, of course, it would be not only an aesthetic. This would be at the same time programmatic. The dense district, of course, is a different life, where you literally can walk from building to building. For this district, where the buildings are become more sparse and more let's say solitary, so they will be different of different characters. So we then obviously would map a differentiation of life, urban life,
right,
onto the and you would generate a stronger overall figure, because what kills figuration or is any decision which becomes random or isotropic. These are the things we have to avoid. And the moment the spacing is isotropic.
Yeah, I just want to reinforce, I just want to pick up on, I think this is really fascinating discussion. I really appreciate what Marta's saying about the other logics that could come into play at this stage, or an understanding, because I think that's what would create real differentiation and also different relations with the surroundings. Because one of the maybe questions is, if it has this larger urban, let's say even metropolitan scale in the infrastructure, it would be another logic that would also help to deal with the edge conditions, which right now are quite, simply truncated. And that, I think, has to do also with maybe an understanding of the metropolitan scale, these different nesting of scales and different kinds of, let's say, actors and material logics that would come with those. And I think that shows a question that is related to that is when we get to the lower buildings, the smaller scale buildings, they have the same kind of articulations as the taller ones, which suggests this is not about optimization only. Which is fine, because optimization is going to solve all the problems of architecture. So I think that could provide another logic for those other elements in the scheme and make for another level of differentiation. But honestly, I don't think these students could be expected to do more than they've done. I think this is a tremendous amount of investigation. And I also, was intrigued to hear that there are the other projects took different strategies. And I think that's also fascinating. And unfortunately, we don't get a chance to see all of them and to have the discussion that would include that, because I think that would enlarge the scope of our understanding of what's at stake here. But I have to say also, just since I think we're probably up against the clock, I do think there are some other really interesting innovations and thoughts inside in the interiors. I really appreciate, for instance, the challenge to stratification in the towers, the use of those wood floors, the inserted floors, and the hanging system of that allows for another understanding of the interior development and interior chunks and spaces. So I think there's a lot of other levels of innovation here as well.
Could I just say a few words here as a non-architect? And hello to the rest of the panel. Yeah, I'm an industrial designer, so I look at these things slightly differently. Where to begin? I mean, the first reaction to the project is it has some kind of post-apocalyptic, degenerative aesthetic, and I'm trying to understand why. It looks like a forest that's just been painted white, and so that could be very beautiful. Okay, so just to rest that for the moment. Then you take the other idea, the idea of cellular aesthetics. And Marta touched on something I was going to talk about earlier, which is the idea of this sort of calcific erosion of the terrestrial plane, and what that gives you. And what I get tired of seeing certain architectural projects is that you get a horizontal plane and then you get a thing just standing on it. There is no fluid liquidity that starts deep before they grow up. And I come from a place in Wales which has the second highest and lowest tide in the world. And when the water goes out, you leave these rock pools. It's absolutely very beautiful. So I just don't see any of that. I don't see any biological life at the terrestrial plane. So that's one comment there. I think the whole thing could benefit from I'm talking to the students now because I think the students have done a great job, and I want to compliment them because I think they work very well as a team. I think they're a great team. This idea of generative design, you know, that's just a description that's been around a long time, but what does it mean? And so if you take generative design combined with erosion, you start to get a question of scale. And one thing I fundamentally don't understand, and you can shout me down if you want, is why on earth build these incredibly beautiful growth structures and then put flat, boring surfaces into them? It doesn't make any sense. Where is the scaling of porosity? And I'm talking about down to a skin level, right? I'm talking about micro levels. Some of the first images they showed in introducing the project were showing these fantastic internalized bone structures, if you like. Well, why can't you build floors like that, which are built from multi-materials that allow light to penetrate everywhere? So that's another thing. The secondary thing is it only appears monotonous because of the way that we're looking at it. I think in reality, if you, at human scale, if you were there, you wouldn't find that monotonous at all. Because you just look at it from a human scale. And as you move through it slowly, I think there's just so much information there. And there's that one animation that they did, which I thought was really beautiful, which was showing the light transition through the building. That connected to the MRI way of describing layering. Oh, God, boy, that's fantastic. But then they let themselves down because then you have this, these louvers and screens, which are no better than what you see in the library in Paris, really, because they're just so dumb. I mean, where is the perforation at different levels and thicknesses and layering, really sophisticated layering? And on top of that, why is it that all external structuring has to do what it's told? Why on earth can't you just have things that fly off and do nothing? So that the absolute sculptural dimension of a building is leaving something for the future. You understand me?
I mean, Ross, I love the way you're talking. And by the way, you might like this idea. At the beginning, we were talking about drone swarms, which are the louvers, which fly around from building to building and shift and migrate around it like a flock of birds.
Incredible. I mean, this is the question of scale. I think they've got everything here. And it's an incredible project. And if these floor plates that keep popping up are really beautiful. So coming back a little bit to Marta, you know, a little bit what Robert, everybody's been saying, I think that it's a hell of a body of work. I mean, good God. So I don't want to be critical, but I think if you got into that depth, like that image, and you push that out, you got into this layering at almost a fabric level, biodiversity within itself.
I love that.
Amazing, actually. And then there's no color in it, for God's sake. Put some color into it, and then you got diversity. Just project some light onto it.
Absolutely. Hey, Ross, you get it. It's that's the dream of the project. So I sign that right here. It goes straight into as an instruction.
I've been loving what everybody's saying, and you know, I'm sitting here with my hat on because my studio is so bloody freezing. It's
oh God. I thought it was a great statement, though.
Yeah, just in terms of wrapping up this
project. I think we need to move on. Yeah.
It balances overall look, though, Ross. The white. You know, it's very symmetrical. Very old school of you.
Well,
there's just one thing I do want to say. I don't have any response to what Ross just said. I think they're great comments. But before you get to all of that, you need elevators, some way of moving up these towers that would actually change the form, because I think that if you have multiple elevator banks, I mean, Patrick, you know this better than anyone, it just adds multiple costs. Anyway, forget about that. But
sure.
One thing I do want to talk about, generative design plus erosion that Ross just brought up is a very interesting concept. Wouldn't that become just degenerative design? Anyway.
I know where your kids are in school, so watch it. Okay, I was joking. Just joking. Okay, didn't get that. Cool.
I think in terms for the students, as they're taking all this feedback on, I think a lot of the comments actually obviously have a lot of parity with each other in terms of thinking maybe beyond the conventions of the division between architecture and infrastructure. I think if you think of them much more integrated, then the landscape actually starts to really set out the time-based aspects of phasing. It also creates the opportunity to extend the existing kind of hydrology and water management systems of Thames Gateway and really starts to serve. I think you guys have gotten a lot of really good comments, but even to the points that Ross is making about structure that maybe doesn't have purpose yet, in a very rough way, if you think about it as an infrastructure that has a becoming, that not everything needs to be planned. I think the things that you guys have done that foreground, I think, in my opinion, some unique aspects to the delivery is that adaptive nature of these kind of abilities to look at the mega form of the structural optimization and subdivide that. And I also think to look at this urban ground, which you guys have created, which I think also has a lot of things to do beyond just water runoff and water retention. I think that you guys are for sure needing to sort of problematize how that stuff actually really does migrate through the building. But I think on the overall, this project started with really looking at towers, but I think the aspect that's maybe the most unique about this is the urban ground and the operational landscape aspects that you guys can contribute not only for this development, but also for the areas around, which are in flood zones, as your analysis actually was bringing up. So I think that you guys have gotten a lot of really good feedback. You guys have 2 weeks to kind of make some sense of it, but you guys should be commended on putting together, I think, a really good conversation and discussion around your thesis, which I think is really what is a real success in terms of evaluating what you guys are doing. With that, I'm mindful of time as well, that we have to continue with the next project because we also have a lecture post this. And if that's okay, thank you to the students and for the great comments to the critics, and we'll move on to the next project.
Thank you.
Thanks, thanks guys. Are you guys ready?
Yeah. Yes.
Okay, so whenever you're ready, go for it.
Yeah, let's start. Good afternoon. Thank you all for coming today. We are from Pseudo Spiropoulos Studio. These are my partners Zheng Ze, Hao Yang, and me, Han Yi. Our world has suffered from unprecedented challenges. Our team believed that we should respond to the problem with our research. Bringing hospital to you aim to provide more patients with the possibility of care at home. This means that they could be treated in a more comfortable and intimate environment. By using real-time distributed system and robotic frameworks to decentralize medical resources can help to augment existing healthcare system, which give an opportunity to open up a new world that is much more humanitarian and customized to patient care.
As Susan Sontag mentions, illness is a nice side of life. It should be considered as a regular part of our everyday lives. But the reality is quite the opposite. People are more willing to treat illness as metaphors which expel the patient from the society. And the contemporary design of hospital in fact enhances this kind of alienation. The architectural logic of modern hospital reflects the idea of panopticon, the paradigmatic diagram of surveillance and management. Meanwhile, the traditional centralized logic of medical system is failed to deal with the complexity in real world. Hospitals are usually too crowded when we are as outpatient and too isolated when inpatient. They can also be easily overwhelmed when there is a public health crisis due to the lack of organizational capability of centralized system. Furthermore, experiences in hospital are usually intolerable for the patient as they are isolated and monitored by emotionless machines. Lonely and anxiety then becomes huge obstacles to recovering from illness. Though the healthcare system nowadays is centralized, but the treatment process of every single patient is in fact decentralized and require high level of collaboration. Treatments are processes based on collectively working, which requires communication among many different types of devices and doctors. But all these processes are organized in an inhuman centralized framework. Thus, in order to provide a more humanitarian and efficient medical system to the people, we need to extract the decentralized treatment process from the centralized hospital and directly distribute the healthcare to everybody and make it self-organized and also able to deal with the problems in real time dynamically.
This is how hospital operates nowadays. Hospitals are static, passively dealing with the ever-changing medical needs. Patients visiting the hospital from different places despite their accessibility. In hospitals that are centralized and static, patients with various disease, age, level of care are being treated. They require specific medical staff and treatment plans with matching medical equipment and resources. But all those things are in different areas of hospital. Actually, today's hospitals are using centralized and fixed building to respond to the changing needs of patients. In contrast, ambulances are more flexible. They have different sizes equipped with corresponding medical kits for specific patients. They can be adjusted according to the patient's need. This is kind of mobile resources units that are treating people based on their need and brings healthcare to patients. Instead of having the patient visiting the hospital, deliver suitable medical service to patients is a better choice. What's more, we found out that 46% of patients treated in hospital are also suitable to be treated at home. Therefore, we believe that a more mobile form of medical operation and decentralized network system would provide a better medical service to patients and more able to cope with the ever-changing condition.
To make architecture distributed, we look at the precursor cases. The relationship between vehicle and architecture, like Marina Tower in Chicago, Frank Wright designed various mobile machines in Broadacre City to let the public enjoy resources centralized in the city center, and Michelle Webb's driven in-house make the architecture more radical in transformation in real time. Now there's a new world that by working across science, technology, art, and design that move beyond the fixed and the finite of the past spatial environment that are adaptive and emotive. Also, the autonomous disinfection robot, free the human intervention, and the Boston Dynamic robot is enabled remotely monitoring patients to reduce the risk of infection. Remote surgery and the clinic are developing more and more credible and safety. Those robots and the AI technology is helping to solve problems for medical resources can be distributed.
Then we try to construct a control system of medical resources management. We looked into navigation systems such as Waze and think of them as self-organizing distribution systems. By encouraging real-time communication among users, the traffic information not covered by a centralized system can be spread by every terminal, which allowing the distribution to be more accurate and faster. Inspired by Waze, we try to simulate how the system agents will achieve real-time communication on the different route sets. Simultaneously, transportation relocation systems also help construct the framework that allows medical resources to be delivered to everyone. Such a system will update and adjust constantly based on continuously changing medical information. Afterwards, different distribution patterns merging by scattering and flocking behaviors are being tested by simulations to deal with various situations. By considering the complexity in real urban context, the system will get access to several infrastructures and types of information in the city, such as hospitals, charging points, and obstacles in next-step simulation. Patients are also divided into specific groups that require different treatments or equipment. Thus, multiple layers of units with different functions are being introduced to fulfill the various requirements made by different people. Based on the previous simulation of distribution pattern, the units will perform a flocking behavior to travel and deliver treatment in the city, but need to be contained in a global carrier to keep the delivery process safe and hygienic. Units with tasks will be released from the carrier at a certain distance with the patient based on their speed and endurance. After their tasks are finished, a decision-making process is taking place to decide which carrier to rejoin. The communication during this process will also notify the carrier to wait or pick up the joining units. In order to negotiating with urban and domestic spaces, multiple types of mobility, including walking, flying, and fast rolling, become one of the driving concepts of the unit design to provide the capability of adaptive distribution. The diversification and self-organization character of units will help customize each patient's own treatment process based on their requirements and circumstances. The order of treatment is made by a decision-making process that analyzes the illness, waiting time, and priority level of each individual patient. Different units can self-organize to deal with complex tasks on the grounds of their different mobility methods and internal structure, which allow different medical devices to assemblage and replace. Besides, with constantly communication among each other, units will decide their destination and which body plan to form to occupy public spaces to organize the treatment delivery processes. The units can also utilize infrastructure such as elevator and staircase in domestic spaces due to their negotiation with surrounding environments.
Here is the flowchart of the system that we want to build, not to replace the existing hospital, but to act as an augmentation to achieve the decentralized of the medical resources with mobile units, bring the hospital to patients. Actually, behind this system, this is a complex urban landscape that we need to deal with. From the hospital to patient's home, our units need to correspond to a large number of medical resources, different patients, complex urban traffic, including vehicles, pedestrians, and traffic lights, etc. And also the stairs, elevators, and windows in patient's home. The infrastructure in the city is very complex. Medical resources also have different users, size, and weight. After this, we start design of the unit. We want to give mobility to different medical resources in the hospital. So at first, we use modular medical equipment with flexible geometry of monowell to spread medical resources in the city. Equipment unit can be moved to different carrier units. However, we found that this design was not flexible enough to cope with the changing situation. Then we thought that each equipment unit can have a rolling mobility like a monowell, and they could also transform into different shapes to achieve different mobility, like climbing stairs. The version also allows them to attach the patient's body for treatment. Afterwards, we designed the final version of the unit to be more flexible, which have different sides to cope with different medical resources, as well as units can carry patients, and they have different mobility to deal with the complex urban landscape by walking, flying, rolling, and different combination between the units. For the combination, we use electromagnets to connect them to each other. There are 14 or 8 gray magnetic points on the sphere unit and 8 areas on the ring unit. The size of this unit is not only related to the size of medical resources, but by using this proportion, a high density of packing can be achieved in both 2D and 3D, and they can switch between the two states. By this way of connection, a large number of body plans can be formed, 2D, 3D, with or without patients. Each of those body plans are meaningful. For example, this one can be used to treat the diabetics, and this one can be used to treat patients who live on the second floor. And this can be used to treat the patients on his way to hospital.
So there are 4 characters in our multi-layer system. The first is the walking unit, which uses the soft body strategy, which is sensitive and soft for touching a human body. The legs of the unit are the components of the machine combined by mechanism and the electric magnet system. The transformation from spherical and spider-like unit by using inflation and deflation strategy of controlling each leg of the robot. There are 2 functions of the unit can be achieved. The first one is the CPR robot. By controlling the legs' vertical movement, the soft strategy gives a flexible adjustment for fitting with different body shapes. The second is for generating deformation of the leg and a force to hold up the body when people in a trauma situation. For example, the immobilization of neck or spinal problem. The second is the flying boat with structure frame is a high stiffness with light weight by using the advantage of carbon fiber. Camera and sensors are capable of detecting on the street and identify the specific patient. Flying unit will release medicine to the people who have the right code on their phones. It's designed by replacing the small inside vessels. We can change the unit in 2 modes. One is for the containers of the medical devices and the other for the vaccination operation. From the previous experiment from Japan's Ministry of Defense, We know the flight time is limited about 8 minutes continuously and the speed up to 6 km/h, enabling to achieve local mobility near the residential. And the third is the rolling one, which is designed for fast speed move on land. The function of bulky medical devices can be stored inside the rolling robot. And the oxygen concentrator needs autonomous and high mobility for people who need it, especially in the current epidemic situation. The NHS data shows 18 of infected people tend to change from mild to severe due to the ventilator shortage, which the unit can make contribution.
The fourth is the carrier unit. Its design is based on structure of model well, thus enabling a long-distance mobility in the city. The middle layer stores battery and medical resources to resupply other units. Those units will leave once resupply is complete. The inner layer can be rotated in both X and Y axis direction to organize the equipment unit, and it can also use to aggregate with other carrier units. This part can also use to unfold into a chair when needed, while the outer part can form a space for patients. This shows the state of carrier units in the city. Some of the units are on patrol waiting for orders, and some units are carrying patients. Some units are carrying the medical resources to its destination. When the demand for medical resources is low, for example, at night, fewer carrier units will continue to work in the city, and some of them will aggregate on the side of the building to reduce the occupation of public space while charging and resupply medical resources. We have many different sensors on our unit to sense the environment, our other new units, and human. With those information, our system can find the best solution for different situations.
Communication between units and surrounding environment is done by sensor system which combine camera, radar, and laser focus sensor. Camera data is used to perceive objects in its environment. And with collaborate working of radar and laser focus sensor, units are able to calculate the distance to objects and predict their possible speed. By reading the road traffic information, estimated arrival time can be calculated to decide the distribution of medical resources. During the real-time decision-making process of distribution, the system will automatically match the unit with the patient based on the analyzation of road traffic information. With all information acquired, units are able to avoid any obstacles on the city roads and auto-drive to the location of patients who are assigned to them.
And the unit interface with human by using habituation and a pattern recognition system, and also the thermal detection. The robots are able to obtain the healthy data like a heart rate and temperature of the specific patient for testing and monitoring.
The communication between units is achieved by expressing different states through 4 different blinking frequencies. Through the communication, they can cooperate with each other to achieve different goals to cope with different situations.
To prevent the population from either too small or too high, multiple simulations with a different number of units in place are constructed to decide the formula of calculating quantity. Area and disease rates are the same in this simulation, so it will be evident for us to see which level of units quantity would be appropriate under certain circumstances. By running simulations for a period of time, the results have shown the different abilities to treat the patient. Based on the results, we can deduce a population formula which is based on the measure of area and also disease rates. As cities are usually crowded, the system requires the capability to communicate with urban context. All units will get access to road traffic information and analyze them with navigation strategy which applies real-time communication. The traffic information will be downloaded from navigation apps and also acquired by the unit's own sensors. Then a full awareness of which route takes them less time is developed by the units. When the initial route is considered to cost too much time, they will automatically reroute to select the fastest path. In addition, the process also relevant to their priority level. Units with emergency tasks can alert other units and road traffic to give way to their attempt of saving lives. As all the units are driven by electricity, they can utilize the city's charging points by real-time communication. The carrier units also function as a platform for other units to charge and resupply. Electricity in the carrier unit will be used to provide power to its engine and other units inside. When electricity running low in carrier units, it will automatically communicate with nearby power station, get access to the information such as distance, status, and location, and then decide which one to go depending on both the situation of the power station and the road traffic information. After the charging process is finished, they will continue working on their previous task and charging other units that join them. The destination of carrier units are in continuously changing due to real-time communication. For instance, when an emergency situation occurs, nearby units will be alerted and go through a communication-based decision-making process to decide which one should change their current task to take emergency actions. From the view of the system, the destination decide process is based on the data of the diseases in the city and the communication between carrier units and equipment units inside them. During the process, carrier units keep monitoring the status of equipment units inside to see whether they are urgent or they share a similar destination. When a high priority patient suddenly requires certain treatment, the system will connect the patient with equipment units that carry a particular device first. After that, the unit will communicate to nearby carriers to decide which one to enter. The emergency cases active carrier unit will transfer the initial low priority patient information to other units nearby and change the destination to the place where the emergency happened. As the process is communication-based, the destination will change dynamically and enable the finite medical resources to be redistributed through robotic frameworks that meet the individual scenario's needs through decentralizing of medical resources. Medical situation in real world is constantly changing, so the distribution of the units also needs to be adapted. To tackle the complexity, machine learning strategy is used to analyze the disease rate in different areas. Disease cases which categorized by their cause, rate, and quantity are being recorded to figure out the pattern of the emergence of illness. By analyzing historical and current data, the areas which have more possibility for certain diseases to emerge are highlighted and will rise their priority level for units which are relevant to them, and also become a reference of distribution management process. During treatments and diagnosis, lots of disposable medical devices will be used, and the equipment units need to get their supplies from the carrier unit. The resupply process of carrier unit is also communication-based. If the disposable equipment in the carrier unit is not running enough, in that case, it will automatically communicate with nearby hospitals to obtain information such as distance, status, location, and waiting time, and then decide which hospital to go according to the hospital situation and road traffic information. At the end of the resupply process, they will continue to perform their previous tasks and provide supplies to other units that join them.
In the urban context, units enable individually and collectively achieving the goal in the city. By communicating with each other, units are enabled to make a decision to choose the quickest way for bringing treatment to the patient home. Flying behavior breaks the limitation of vertical mobile in specific domestic space. Sensors and the virtual AI technology support patients with remote clinics and bridge the conversation with doctors. Unit also can be stay with patient for monitoring on long term, depending on the condition of patient. Large amount of units also fit with the mask or vaccine releasing scenario. Since the walking robot as the CPR function is urgent for patient to obtain, the combination with the flying one can help it flying through the window to target the patient home. Sensor and camera working together to support the program, and the part of a unit as the respiration machine collaboratively work with the cardio compression robot for blood circulation and keep breathing. For the emergency scenario, like after a car accident at midnight, a patrolling robot found the situation and sent it to the system. The network calculates the surrounding units by evaluating their current task hierarchy, and then the unit with no task or the low urgency task will immediately activate it. Furthermore, the system decides the proper number of units to go for the site, which work with the existing medical care system at the same time. Also, our unit can work with the existing infrastructure and the urban space to reduce the pressure of the testing problem. Like here, a small park in London, the unit deployed on both ends of the single path. One is for releasing the kit box and the other for the returning one. It's easy for people from step 1 to obtain the kit box from unit, and the step 2 to do the test in spatial unit, and the final step returning the box to the unit, which autonomously prepare for the next user afterwards. The distance after unit full of boxes, it triggered the navigation system for searching the nearest available lab in the city. After the testing work, the lab uploads the data to the network and the user will get a test result immediately. At last, we want to test problem with the vaccination. Think about how it actually happened. In England, the vaccine is being offered in some hospital and pharmacy run by GPs, but we thought the best way for everyone to get a test or vaccine is at home, being isolated, and people will not come together. The system will sort out the data of people who from the same area applying for vaccination online and obtain the information such as age and the previous medical history. People who over the age of 80 or have underlying medical conditions are the most vulnerable group to against the coronavirus. The system will calculate the hierarchy of population and balance the number of vaccines to deploy them to the people. By using the camera sensor, units are capable for recognizing the specific user and trigger the actuation of injector. After target to the proper area, the action is like a mosquito stabbing into the muscle, give the injection and disinfect the skin in the end. After the flying bolt of vaccination mode leave, another monitoring robot will come to stay with the patient for 30 minutes in case of allergic or severe reaction. Carrier unit will collect the robot after finishing injection to provide the disinfection for all of staff. 10 minutes cleaning cycle aims to reducing the spread of virus and the disease to make sure the whole ecosystem are safe to give protection for people. Thank you for listening. Thank you.
Thanks, guys. We can open it up for conversation.
I'll just jump in here. I have to say this is an amazing, my mind is blown. I haven't seen anything this relevant in quite a while. And the way in which I think starting with the Sontag quote of illness is part of life, I think is such a wonderful point of view that's carried through at every level in terms of the integration and thoughtfulness of this project. I think that, that one of the things that's really cool and I think contemporary about it is the notion of hacking into existing platforms that, that everywhere you're, at least in many of your studies, you're using existing infrastructures and platforms that were not put there necessarily for care. And you're redirecting them and repurposing them, which I think is really brilliant because these things are so capital intensive that you can't imagine creating another one. So I think using all of those platforms for other purposes is really what we're, I think, facing in terms of any kind of innovative design to begin with. So I think that's a very relevant aspect of the project, as well as the content and the actual repurposing also of motion, a lot of technology, again, hacking into these technologies of mobility that are being developed for delivering, pizzas or whatever, but now could be understood to actually be serving a distributed healthcare system. And I think we've become, in this past period, all of us, of course, have become much more sensitive to an understanding of the disaster of design relative to healthcare. And the scariness of the hospital as a model. And also its impossibility. I mean, right now I'm in a city where the hospitals are just totally, absolutely overwhelmed with only one kind of treatment. While, you know, this is just not sustainable given the, you know, reality that these kinds of epidemics and so forth we're just at the beginning of something, not at the end of something. So I have to say, on every level, this is a really tremendous project. I think it's also humorous in some ways, I mean, which I appreciate, that, you know, that there's a kind of combination here of, you know, fantasy and rational thought, which I think ties it to an architectural proposition as well, a way of thinking that brings an architect's point of view to these problems, or to this problem situation. So I think it's a tremendous project.
Peter, it's interesting you describe it. It reminds me of Minority Report, but a future version of it, where there are no precogs determining the future, right? So I do appreciate your comments, and I mean, I completely concur with you, you know, and with regards to the currency of what we're living through, to then sort of decipher or understand the problem to such an extent where the solutions are so carefully thought through. I mean, there's particular moments within the city I really enjoy thinking about. I love the distribution of healthcare, right? Peter, it would be great to have a robot come and treat you, right? In your home.
Absolutely, absolutely. What could be better?
A teledoc conversation with your doctor today is more interesting than having to go wait 45 minutes to see the doctor in person. So if the diagnostics are up to that level or that scale, it then becomes quite a feasible model. I mean, I'd love to be interrogated by a robot, you know, really. And also, you know, I mean, I just want to say one more thing. Look, I haven't seen Theo's work in a while, but the tendencies of kind of the heavy research, right? And how it shifted towards becoming so contemporary and its paradigm, in addition to all the things he's always been interested in, like pneumatics and, you know, distribution systems and these super designed sort of objects. All of that is retained, but in a very, in a sense where it is so contemporary. I mean, this project is, I love the research of it. I think it's so sophisticated and it's hit every level. And I think at times it's mirroring what's actually happening in society. So that's also probably a reason why it's so contemporary. And that's the question I have, is the two versions, right? One is this plays out in the future, right? In 10, 20 years, and this is kind of where hospital infrastructures go. The other way of thinking about it is that it's a momentary revelation to where we are today and what it could be potentially. But then no one can tell what's going to happen in the future, and maybe it just completely morphs into something different. So I think that would be an interesting discussion for me to kind of understand with regards to where the students think this project is located. Do you feel that it's a moment, like contemporary in the sense that it is so contemporary today, if this was out there already, and this is a momentary glance into something, or do you think this could actually be, it could have robust potential in the future? Because I think the contemporaneous nature of the project would potentially change based on so many factors in the future, right? So do you think it's more or less contemporary, I guess, with regards to its finiteness in time?
Well, we think technically it works in contemporary era because all the technology we use, they already exist, but they just need someone to put them together.
And we thought that the traditional architecture is a finite. I think especially for the coronavirus, the epidemic situation, and the people had to queue up the fixed building to get the test or get the vaccinations. And even for the people have the other health issue are reluctantly to go to hospital because they are not want to take risks to get the infection of coronavirus. So I think in the future, all this kind of technology and a robot is really helpful to distributed architecture to build yes, I think it's a better world.
Yeah, it makes me think about how fantastically sophisticated human beings are. And I say that because in a studio like this, we have a system, a thought, which can arrive at what we call the hole in the bucket, which means you fill the bucket full of water, you come back from lunch, and there's no water in it. Because there's always something which is wrong, which is either the key or not. And we love the utopian fantasy of this, and I kind of encourage it to some extent. But in the creative process, your students, do you criticize yourself? Do you look at other ideas? Or you just find an idea and then you go full on with that without questioning it? Because you've got to layer this one out, okay? Meaning, from a practical point of view, and I generally don't speak this way with student crits, I've got type 2 diabetes, I got other stuff. My partner's just about to give birth, so I'm gonna say my bit and I've gotta go. And I can't even enter the hospital, okay? But she can't have a birth at home because it's too dangerous. And we got COVID and we got all of that. So there's these layers. You can't be so simplistic about it, okay? So if you're making some form of diagnosis which is related to something cardiovascular, blah, 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 you can do that with an intelligent mirror, which is basically a television screen that could be assigned to everybody's home. If you look at what people pay for their gadgets and objects at home, from a television to, I don't know, food mixer, to a jacuzzi, to a Peloton exercise machine, you add all of that up. I would give all of that up just to have a screen on a wall that I could talk to that would give me diagnostics from a child, for a temperature, that kind of thing, because that takes the weight off the health system. That's something which is not critical. It's not an emergency situation. Now, if you get into an emergency situation, as you showed with the traffic accident, human beings going through such a trauma can't lift themselves up into a wheel. They can't do that. So ironically, that's the hole in the bucket you've got. And I'm not here to be overly critical, but please layer it and think it through, because it's very seductive and it's a big issue. And it's going to come. So, there's other examples of that. My friend Greg Lynn is working on something, and Greg has holes in his bucket, okay, which are going to be problematic for his product, okay? And I know Greg very well, doesn't carry enough stuff. It's very heavy to put in the back of your car, doesn't go up steps, dead. So think it through. Because instead of trying to get a hammer and hammer down the door, just take a key out and turn it by your thought process, okay? Because it's a digital realm, and the digital realm negates movement. It negates physicality, allows us to put something on our wrist, check it, do all those sort of home diagnostics. They're very, very different than having a major accident and then having to go to an emergency situation. So you've got other interim opportunities like an A&E on every street corner. Beautiful. You know, I don't know. I'm not, I love the way you presented what you've done, but I'm resisting seduction because I think there's a practical dimension that if you got into that, it wouldn't undermine what you're thinking. It would enhance what you're thinking. Okay.
Yes, that's an interesting question. Yeah, we agree with that. And yes, but as the augment of the existing hospital system, we want our things not cover all of those like practical things, but we think that it should be some distributed medical resource to deliver to the patient, not just a screen to monitoring or testing those things. So that's why I think that's the point of our system.
Because they can't go through a window which is not unlocked. And if an old lady collapses, she's not going to open the window for the drone. So, you know, this, I'm sorry, I never talk this way because I don't want to kill anything, but there are these issues which stop you in your tracks and make me think, where's the hospital, which is like an incredible sponge, which allows drones to go through its roof and, you know, this kind of, where's the architect? I mean, you could go back to a hospital now with a combination of what you're showing and the mothership, if you like, you answer, and the mirror on the wall, mirror on the wall. You cover every possibility.
I think those are absolutely relevant points, but I think you could also, I love what you're saying at the end about going back to the hospital, because I think in a way this mode of working by going to the extreme, by going all the way down with it, it also reveals all of its, let's say, holes, okay? It starts to, but if you only went halfway, you'd be left without the ability to have that kind of, let's say, understanding what the bucket is and where the holes are. So I really appreciate the comprehensive and obviously the window issue. I mean, sure. But you could then start to say, well, maybe there could be secondary clinics or some other space that was made that didn't have the heavy infrastructure and equipment of a hospital because it's too expensive, but could actually share equipment through these kinds of means. So I think that it's the beginning of something, and I agree with you, you know, it's like the Apple Watch going to the extreme, right? Like that this is going to happen, as you say. And I think that this is, nevertheless, this is the first time I'm seeing something this comprehensive in terms of also all of the communication devices working together and finding those places where it breaks down, right? That's part of why their presentation, I think, is so awesome, is because it actually reveals where it doesn't work as well.
Yeah.
Well, I think also that's I think the most important part of doing design research is also identifying very clearly problems. And I think one of the things that I think has motivated the studio is, in one sense, to target some of the research that we've been doing over the last 10 years towards problems that are both strategic, both have design aspects to it, but are also motivated with problems that actually don't have solutions at the moment. And they're identified, but there isn't a design community that's really actively engaging it. And this is somehow, in our ways, trying to take some steps in that and participate in what we think we can contribute. That being said, I think the issues of extending the hospital and health and well-being, to go to Ali's point, is very important, where, you know, things that can be treated, and this is something that happens living in London very every day, honestly, is that most GPs are going to phone you. If there's something, you can come in. There is a kind of telematic aspect to certain aspects of diagnosis and things. Vaccination, I think, is a thing where, you know, now you have pop-ups in different locations. And if there is a way to deal with a more kind of clinical and safe way to do that by dealing with it in a more distributed way, I think it's just to try to kind of galvanize around some of these issues. And I really appreciated Peter's use of the word hack, because in some sense, I think is what makes it something, like Ali's talking about, contemporary, is actually looking at how a lot of these different platforms have been developed. And usually those models are attributed to very different kind of business models and so forth. But actually in this moment of crisis where we actually really do need robust systems, we see it in the UK with contact and trace, that when they are trying to be built from the, from scratch in a moment of crisis, it's not possible. These are solutions that have to somehow bring a kind of knowledge economy together around these kind of issues and sort of put a kind of social mandate to try to find a thing. So I agree about people being picked up and all of these things. And I think it's a great comment coming from you, Ross, at this stage, because at least from my perspective, I would want to encourage these students to continue down this path.
Well, the thing is that, Theo, I would love this to work,
I think
cities need this. I mean, the modernized civilization of cities is not only, the buildings, it's the whole gig, it's the whole infrastructure. And, from pollution to everything, every aspect of it. And, if the only things we see around us which are modern and developed are cars, then I think it's an absolutely sad world.
No, I agree with you, and I agree with your critique as well. But I think in terms of the value of seeing the project, like we're not making this as a pitch to us, an accelerator at this moment. But to be honest with you, I am hopeful that we will, in some sense, when you look at all of these things and you look at these ideas and you look at these technologies and bringing people together, when we try to refactor what the role of architect is today, I think part of it is also extending the spatial paradigm. And I can say, like, if we can extend the problem of having hospital beds by thinking about using the domestic space as an extension of the hospital system, and to try to find a way to target some of those issues so that people are affecting those kind of problems, I think we're finding a way to contribute without always considering building as a solution. So I think the comments are all spot on. I just mentioned it from my side because I also think the students are receiving it in a very positive way. So as critical as you guys want.
Theo, I just want to comment a little bit about what Ross just said, which I find very interesting. Is like, why are cars the only new things that we see, right? Making so many changes and developing so quickly. The reason is that it's got the most finance behind it. It's got the most funding. They have $500 billion in research dollars a year globally versus even the military that only has 120 billion globally, right? So it's more funded than the military. So if we can figure out the financing behind innovation, then I think we're onto something. I think that's a much larger problem, and that takes education and good leadership, etc. The second question I have is, I know this may be a US problem, but I have a feeling it's a Western problem in that contact tracing only works if you want to share your contacts, right? So there is this kind of testing, tracing a mantra out there, but I know so many people, there's so many stories that people just do not want to share who they've been in contact with or what they were doing, et cetera, right? So this model is a model that seems to be, for example, uploading your own medical histories, etc. All of this would be part of this. So my question is, would this work in the West? Would someone want to put all their information out there about, the days they have temperature, about what sort of disease history they've had through their parents or genetics, et cetera, right? You'd have to kind of create this incredible database. Would that actually happen in the West, or is it kind of easier to accomplish in sort of a top-down society where you just have to do it and it's just accepted within society?
I think it's too late. I think all that data.
It's already happened.
Yeah.
It's already happened. It's already out there.
I think it is, yeah.
I mean, it'll be interesting to see post-COVID.
I want to zoom back a little bit to kind of the project. I mean, I think all the discussion's fantastic. I would agree with all the points in general. I think the project is, I see it as a more radical microweb Kushkul, you know, like where it's actually addressing more contemporary issues than the Kushkul can in today's. I mean, I'm evaluating the Kushkul now in 2021, and what you're proposing is obviously going far beyond that in addressing a societal need, embracing technologies of today, and trying to come up with a solution that sees a different type of agency in the architect's ability to impact the built environment, which I think is interesting. But I just want to zoom back a little bit and look at how do we evaluate a project like this, which is obviously blending the speculative and the kind of visionary, kind of disruptive aspects. So one way to do that is let's establish the need. Another one is the kind of the technologies. And then I think the other one is the agency in the project at both kind of organizational logistics level and also at the object level. How are these objects designed, and how does that facilitate what they're meant for? So just to starting with the need, I once sat at a lunch lecture by the emergency services, the London emergency services, and at the point where they told me how long it took them to get a paramedic to someone having a heart attack, I stopped eating my lunch. And when I realized that it was more than 8 minutes, sorry, 8 minutes was the police thing recently. It was even worse. It was even worse than 8 minutes. And if they want to bring a helicopter in, they have to land the helicopter in a park, and then they might still be 15 minutes away from, or more from the location. And so they send in motorcyclists, and you know, London's so congested that it's really difficult. So there's a deep need for things like emergency. So it's true that diagnostics can be done on a mirror emergency, and of course not every emergency could be dealt with by a small mobile robot, but there's definitely a great need for that. At the technological level, I think one of the things that's really defining this decade, and we've seen the technology emerging over a number of decades, but this decade, one of the key aspects is what they call Industry 4.0, which is about autonomous manufacturing, but it's about cyber physical systems in general. So the connection between all the data networks and the ability for distributed systems, user customization, linking between, you know, hospitals and individuals on their phones. I mean, we have a lot of this already, but this decade, we really see a lot of developments on that, as we talked about with driverless cars and so forth. So I think the project's very timely from the need and also from the kind of period of time we're in technologically. So then that takes us to the agency of the objects and the agency of the infrastructure. So I think you mapped out an idea for the agency of the infrastructure. The objects, I thought you actually put a lot of thought into that, and Ross has some very, I mean, obvious and good criticisms there, but I think there were some really nice thinking about how to get so much within this wheel design. Like, I mean, some of those things really do make a lot of sense, you know, like, and the fact that the wheel can kind of expand into a sphere, that's certainly possible. The fact that you can have nested multiple entities together is certainly feasible. So there's a lot of things in that, and as Peter mentioned, the hacking of other infrastructure in the city, I think there's a lot of really fantastic things there. And so I found the project really exciting, but also really challenging because it starts to question a little bit where the agency of the architect might be in the built environment. And although I agree it would be interesting to see a hospital typology that incorporates this, I think part of the kind of real kind of some of the more radical aspects of the project is to suggest that some of that architectural agency doesn't happen in that hospital, that it's actually happening through these distributed systems and also through the way you design agency into the objects that are actually performing all these tasks. And I think that's where Ross's criticism comes in. You then have to interrogate whether the design of those objects fits all the criteria you're asking for.
Yeah, but it's a great project, Robert. And I think it's great that the school encourages this type of thinking, which it just breaks down the idea of what is architecture. And it's not standalone, you know, it's a really integrated system. For somebody like me, who thinks in ultimates, and I get absolutely distraught if I can't work at my true potential, my true level of thinking, I just give up. Because I just think that there's this, we're grappling in society with this bloody archaeology of our old cities, which don't allow these things to really function. I mean, we don't even have flat roads here. You know, you can't go on a bicycle because nothing's fixed. I mean, it's so archaic. So, you know, looking at the big picture, that's why drones are interesting, because they don't have to deal with any of that. You know, I mean, they just fly. So I think if you put it all together, I mean, this is just an inception of an idea, which is very valid. But if you grew that out, and you looked at the synergistics, as in nature, between pollen and a plant and a thing, you know, you just look at how all that works. I mean, ultimately, wouldn't you want to be involved in a kind of Mazda way of thinking for the ultimate city somewhere that just proved out all these principles? Whoever does that, you know, people would be clamoring over themselves to live there. You know, pods that filter air, do all these things, just put it all together. You know, the idea of health, by the way, begins with, you know, air quality, fitness, food, I mean, education, all of those things. You know, people don't know whether they got a temperature, whether they got meningitis, so they just, you know, pick something up. You know, I've been ill about 4 times since this COVID came, and I don't even know what I've had, you know, and I'm well in the camp for, I'm told, for, you know, wow, you know, so it's like, I think there's more to it. It's a very layered thing, but the idea of health and the physicality of how you deal with that is a massive subject. It's as big as transportation or architecture. So I commend you on that. Nice work.
It's a very, very interesting project indeed. I really enjoyed it, and I also really enjoyed the way that you presented it. For me, the value here is that architects are involved in this conversation, and that is very valuable. And I give big kudos to Theo, to you, because you're looking at some of these ideas of design, but the prompt that the students have taken is to, you know, marshal the ideas that and skills that architects have to begin to think through some of these ideas through scenarios, through visualization, and through, you know, a way of thinking that, you know, they've been able to tap into thanks to their education. And I think that is, I find that to be a great, and how valuable that architects become more involved in these kind of responses to these very important problems. So the fact that you've taken it into a real-time dynamic and scenarios really gives a great deal of credence to what you're doing. And I've been on a number of reviews which look at, you know, big data, intelligent cities, and so on. And this brings in another dimension, which I think is super, super interesting. So big kudos on that. All to say just a few points. One is that when I do think of an intelligent city, I do think, and that's rolling out. I mean, I do think that this is another layer that we can begin to think about, and and an important one, just as important as the plumbing and just as important as systems of rubbish collection and others, although it is much more personal, but as has been said, that is sort of out of the bag already. But just a few things. I liked what Ross said, which is that, okay, you can look at the parts that are hindrances or problems, but I think you guys can take some of the feedback such as that to begin to actually work through scenarios that might be able to, you know, help through or solve those problems, because this scenario-based approach is quite helpful. So, for example, I see a value in this in emergency situations in the world, you know, earthquakes, you know, just emergency situations that are coming up all over, like in the UN or something, where, you know, you need such quick deployment and looking for, you know, heartbeats to be able to find people in certain scenarios. There are amazing, which might help a rollout in a different way that might, you know, come away from some of the problems that because essentially you need to get this out there as soon as possible, but there might be other ways other than industry or other concerns or tech. But all to say that that is a very interesting idea that I thought could come through. The other one is you will have to see this through in terms of, and architecturally, this is an interesting point, where all these, I mean, you would imagine there are millions of these little circles and pieces that need to charge, that need to go back, that need to be maintained, that need to be, so the hospital here that we're looking at, I know you were sort of taking this as before and now you're redesigning the pieces themselves. But to me, the circle has to continue back to the original, which is the hospital. And now, how does the typology of the hospital need to change in the future, where all of these are going to dock, all of these need to be maintained, all of these data, you know, needs to be, you know, reconfigured and understood and hopefully secure, right? So in a way that so it could back end into solving problems that we currently have, which is, you know, we're not sure where all our data goes in the hospital and who's looking at it, and we're not sure, who knows? But this could be a way in an intelligent city to help, you know, begin to look at some of those questions. But all to say that in these scenarios, you have to see it through, right? There are some, so these granular problems that are you know, are there, just seeing it through in terms of where this needs to go at the end, what that could look like, right? What will a new hospital look like with all of these pieces of information is super interesting for an architect. So I want to bring you back to there too, because I think that's going to be something that is, it's a question, but one that, you know, you guys could take on.
Thank you.
Can I say something? I would like to very much congratulate the team. You got me on the introduction of your pitch, almost. Like, you know, the way you introduce the problem is so convincing. It's so relevant and it's so current that almost whatever you would have proposed for decentralizing the medical response would have been appropriate, almost. So good the pitch was at the beginning. So thank you for that. I think that when you put together the kind of perfect storm between pandemics and climate change, which is happening right now in Madrid, then you have a perfect scenario for this project, because people are not able to arrive at the hospital because there is too much snow and because there is ice everywhere, and actually people are getting injured in trying to reach the hospitals and the care places and so on. So the distribution in this case, the aerial distribution, robotic distribution, should have happened yesterday in this case. So I think it's really relevant project. I want to say that in this pandemic, we have seen also a lot of interesting new developments happening in relation to sustaining your project, like for instance, with the lockdowns, with the locking of all the restaurants, all the food delivery, the new forms of food delivery that have been suddenly imagined, suddenly, let's say, reconfigured, at least here in Amsterdam, very, you know, very quickly. Somehow the kind of restoration businesses have found new ways to deliver you the food at home. So I think that therefore shows that there is a need for that too. And I wanted to say that maybe the how to say, the least convincing part of the project for me, and there I would like to join a little bit Ross's corner, is that I would have liked that the project is always presented as working perfectly. And, you know, in some ways, the presentation is a little bit too long because it always works perfectly. So I would have liked very, very much that you use some of your time in almost like doing a little bit of backcasting exercise, where you say what happens when it collapses and what brings it to collapse. So as a means to investigate what would the system need to resist to, you know, so as a means to say, you know, for example, the charging of the units. I think that Nina's comment is spot on. The charging of the units, how do they charge? Are they ever docked somewhere or not? Or are they always, you know, freestyling in the city? Because, for instance, here in Amsterdam too, in relation to the charging points for the electrical vehicles, there is a lot of innovation that is actually happening for that. But there is also a lot of challenges. Because, for instance, the management of the data on the electrical charging points, the energy storage on the charging points, the monitoring, the maintenance of those points, etc., is a very, very difficult point. So I think that if you would have used some of your time to do a kind of backcasting exercise, by now you would have even more of a developed project and more of a convincing project. So, I mean, I want to congratulate you. This conversation would not happen if it wasn't so developed and so necessary and so contemporary in a way. So, thank you.
And thank you guys for the insightful comments. Obviously, there's a lot of things for the students to think about, and a lot of things for us to think about as we're trying to kind of push work forward. So, like I mentioned, this is the beginning of a new research agenda, and some of the things that we're looking at. I think some of the comments of where architecture reemerges in certain senses, and like if the hospital is going to be augmented as a garage for drones, and all of these other kinds of implications of what it means when these things are embedded within an ecosystem, I think are very important. And I think that they're great that they're being raised. I think for Ali's point about also the car industry, one of the things that may be useful to think about is also that industry is in crisis. As much as they're throwing money in it, that is also being rethought in some ways. And by necessary, I think that there is an opportunity there to also instrumentalize a convergence of a lot of these different technologies in different ways. So I think the discussion couldn't have been better, at least from my perspective. And I think it raises a lot of issues for us to kind of keep in mind. I'm also mindful that we have a lecture at 6:30 that I have to prepare a little bit of an introduction for Albert, who's a longstanding friend and colleague, before he goes for it at 6:30. And I just want to thank all of our critics and the students. I mean, this is day one of 2 days. And obviously for us, it's an amazingly meaningful moment to be able to have a conversation on work that was launched under certain premises, and in some moment, like the whole world had to pivot. And I find it quite inspirational for the students to be able to continue this kind of work under these circumstances, and also to have a group of colleagues that are willing to spend the time to kind of share their thoughts and experiences on the work to help the students also post-life of education, like we all are continuing students in some form. So with that, I just want to thank everybody. This continues tomorrow with 2 more sessions. And yeah, please join us at 6:30 for Albert's talk if you have a moment. And yeah, other than thank you, I'm not really sure that I have many more words to say. So thanks everybody for joining, and yeah, it's been really a good conversation from our side.
Congratulations to the students. Great work.
And it's
Thank
great,
you, everyone.
great to see familiar faces.
Yeah, thank you so much, Theo, for showing us such amazing work. And also, it's great to see everyone. Fantastic to see Marta. Hi.
Hi.
Wonderful.
Are you coming tomorrow?
No, I have other things